The industry's origins in the United States can be traced back to the late 1800s, and more specifically the early 1900s, with the advent of electrically welded steel pipe. In North America alone, about 300,000 miles of these mostly underground pipeline systems transport huge amounts of natural gas each day, serving as the critical link between fuel-producing regions and end users. The pipeline systems continually evolve, being updated with the latest proven technologies as demand warrants or specific area changes dictate. It's more and more commonplace for population and development to grow toward what were once rural pipeline systems. For that reason alone, it's more and more important for all stakeholders to recognize and respect these important underground facilities. One of the leading causes of pipeline incidents is careless excavation practices. Preventing pipeline damage has become a major focus area for operators. Bureau of Transportation Statistics records have historically and consistently shown that long-haul pipelines have the best transportation safety record in the United States. Pipeline system accidents, which are reported to PHMSA, are rare, particularly when one considers the trillions of cubic feet of natural gas transported each year. But the industry fully understands the potential impact of a damaged pipeline and takes many measures to both maintain pipeline systems and prevent these accidents from occurring. The industry has built its solid safety record on a foundation of continuous improvement, and as a result, it has seen a percentage decrease in the number of significant incidents in the past 20 years, while the amount of natural gas moved in that time frame increased dramatically. Every step of the way, these long-haul pipeline systems are monitored around the clock by high-tech equipment and highly skilled employees. The basic process to transport natural gas long distances involves not only the specialized steel pipeline, but related measurement and pressure regulating equipment, compressor stations that compress the natural gas molecules to facilitate the journey, and control centers that monitor major operating conditions around the clock. Companies also repeatedly communicate with those living near pipelines, emergency responders, and other important stakeholders through various methods, while providing strategically located above-ground markers and other means to remind them of their mostly underground assets. An object-free and clearly defined right-of-way corridor is critically important to pipeline companies both during the construction and operation phases. While a temporary workspace width of about 100 feet is generally required during construction, the permanent right-of-way for a long-haul natural gas pipeline is typically 50 feet wide or roughly 25 feet on either side of the buried pipeline. This helps identify the presence of an underground pipeline. On the right-of-way, work site preparation begins with the removal of all trees and brush from the construction work area. Stumps are removed over the width of the permanent right-of-way, with the exception of stream buffers and wetlands. Specialized heavy equipment is often used to assist in this process. Downed timber is often cut into usable lengths or otherwise disposed of after seeking landowner input. Grading is conducted where practical to provide a relatively level surface to allow safe operation of the heavy equipment required to excavate the trench and install the pipe in the trench. A trench is excavated that is wide enough to safely support the depth of the trench and to allow lowering in of the pipe without damage to the pipeline coating or harm to construction personnel. In some rocky areas, blasting will be required to excavate the trench. The steel pipe sections, or joints, in 40 or 80-foot lengths, are trucked to the construction work area and strung out along the route in the areas where they are to be welded together. As necessary, the pipe joints are bent to follow the route of the pipeline and contours of the ground. A specialized pipe bending machine is used. The amount of the bend in the pipe section is limited to avoid damaging the pipe or coating. Once the individual pipe joints are bent to fit the trench, they are welded together into long continuous sections which can be up to several thousand feet depending on terrain. The welding is highly controlled and performed by welders using proven international standards. Each weld made on the pipeline is visually inspected, and the welding process is verified with either radiographic or ultrasonic technologies. Welds that do not pass stringent requirements are repaired or replaced. A specialized corrosion protection coating is applied to each of the weld joint areas after the inspection is complete. The coating on the entire pipe section is then electronically checked for any coating problems and repaired prior to lowering the pipe in the trench. The pipe sections are lowered into the trench by special pipe-laying tractors called side booms. Care is taken to not damage the coating during this process. The pipe is placed in the trench on sandbag benches to prevent damage to the pipe coating. The coating is rechecked again. The ends of these completed pipe segments are then welded together in the trench to form a continuous pipeline. Once long sections of pipe are completely in the trench, the material excavated from the trench is carefully replaced over the pipeline. A layer of rock-free pad dirt is placed all around the pipe to protect the coating. As various sections are completed and the trenches are backfilled, the pipes are filled with water and safely pressurized to a point significantly higher than the maximum pressure the pipe will ever be operated to verify the overall integrity of the pipeline. This test pressure is held for a minimum of several hours to test the structural integrity and overall strength of the pipeline and to allow minute water leaks to be found. The cleanup and restoration process starts as soon as practical after the pipe trench is backfilled and continues until the construction work area is restored and revegetated. All terrain is replaced to original contours as much as possible, and the work area is restored utilizing seeding and soil preparation specific to the affected area to restore ground cover and to minimize erosion. Temporary workspaces will be allowed to return to their previous state, either wooded or open. The permanent right-of-way corridor will need to remain free of most obstructions to signal to any passerby that underground utilities are present. Above-ground markers will be placed at locations such as road crossings and at various strategic places along the route to further indicate the presence of a pipeline. The markers contain important information such as operating company contact phone numbers and the commodity being transported. Upon completion of construction, the right-of-way typically may be used for most residential, commercial, or agricultural purposes, provided this use does not interfere with the safe operation, maintenance, inspection, and repair of the pipeline, or obstruct access to and along the right-of-way. Restrictions are documented in the easement agreements, but in general, permanent structures should not be placed on the right-of-way. Some examples of these types of obstructions include houses, decks, sheds, pools, and septic tanks. Also, tall vegetation or trees should not be placed on or near the right-of-way. Some items, such as driveways, fences, and improved parking lots, may be placed over and across a right-of-way if they meet certain requirements to protect the pipeline. Always check with the pipeline operator and easement restrictions prior to beginning any work.
A dangerous shock. A deadly fall. Both happened because a complete job safety analysis, or JSA, was either not done, done incorrectly, or not followed. In fact, almost every accident on your rig today happens because of a lack of pre-job planning. And the best pre-job planning safety tool you have is a JSA. Taking shortcuts and not planning a job properly can cause serious injuries and accidents that can be deadly. A proper JSA, along with a complete permit to work when required, creates a safer, more efficient work environment and effectively identifies all hazards. A JSA will also greatly reduce your chances of being hurt on the job. Just think of a JSA as your first line of defense in getting you and your rig crew through your tower safely.
Took some shortcuts and assumed that the pump was locked out.
A team member whose leg was broken in 2 places found out the hard way why it's so crucial for each crew to perform their own proper JSA. And get a permit to work for jobs that require an added safety barrier.
You know, as soon as that accident happened, what's the very first thing that went through your mind, Ro?
Pain. It broke my leg in half in 2 places. It was excruciating pain, and basically, if I wouldn't have taken that shortcut, I wouldn't be in that situation I was in. We should have all gone up and reviewed the JSA, gone through the proper steps and procedures, and made sure that everything was locked and tagged out before we jumped on, the pump and started working on it. I will do it the right way next time. I will not take any shortcuts.
Take your chain off of that little chain hoist and go through the inside of the liner.
A properly completed JSA will identify obvious hazards or dangerous conditions you're about to encounter, and some that are not so obvious, like stored hydraulic or electrical energy. A good JSA is critical because it gets every job off to a safe start by giving you step-by-step instructions on how to perform your job and do it safely.
Is there any other valves you have to close?
But even the best JSA won't help the rig team member who didn't participate in writing or reviewing it.
And how did we release that energy?
By opening 2-inch fans of things.
Okay, and that.
So be certain to include everyone involved in the job in the JSA review, especially new team members, because a fresh set of eyes may see a safer, easier way to get the job done. Now that you've learned why a JSA is so important to your safety, here's the steps you'll need to follow to complete a proper JSA. First, identify and write down a clear, concise list of steps that you'll need to complete your work safely. Once you have that list, identify any potential job hazards. And take the time to look around and talk about how you and your team members can avoid injury if things don't go as planned. And remember to plainly spell out by being very specific any pinch points, slip hazards, or trip hazards to everyone.
Is there something you have to do first before you break that nut on the liner? Or?
Make certain less experienced hands ask questions and that they clearly understand the dangers they'll be facing. Supervisors should verify this by asking open-ended questions.
What are you going to do to de-energize it, first of all?
I'm going to open up the 2-inch line.
Alcohol and drugs in the workplace. Alcohol and drugs, including medicines prescribed by a doctor or purchased from a pharmacy, can affect a person's ability to work safely. All workers have a duty of care to their own health and safety and that of others. This means you must be fit and well to do your job and not be under the influence of alcohol or drugs that might affect your ability to work. In jobs such as road and rail transport, construction, engineering and mining, the law sets down a legal blood alcohol level and may prohibit a worker from being affected by any drugs, legal or illegal. Some companies have explicit policies to test their workers for alcohol and illegal substances. This is particularly important if a worker is in a high-risk environment or could seriously injure themselves, another worker, or a member of the public. You need to check if your employer conducts regular drug and alcohol testing to ensure you understand your rights and responsibilities. Employers attempting to identify alcohol and other drug-related risks to health and safety should consider on-the-job intoxication, regular use or dependence to alcohol or other drugs that adversely affect work performance or conduct, the possession, consumption, distribution and sale of illegal drugs in the workplace, chemicals used legally in the workplace that can impair a person's performance or magnify the effects of alcohol and other drugs in persons if exposed. Some indicators that can suggest the presence of alcohol and other drugs include near-miss incidents, violence, regular lateness and frequent absences, lack of personal grooming, workers experiencing poor coordination or poor concentration, changes in attitude and behaviour. Always check with your supervisor or OH&S rep before doing any work you are not familiar with, or if another worker seems impaired, and never mix alcohol or drugs with work. Always remember, safety first.
I'm John Ratzenberger, here today to learn about excavation best practices. Like many Americans, I love working with my hands, and the little boy in me still enjoys playing in the dirt. Over the next few days, I'll learn the ins and outs of safe digging from industry professionals and get a first-hand look at some of our underground infrastructure. Did you know that there are over 2.5 million miles of energy pipelines throughout the United States? And that's just one type of buried utility. These pipelines transport products like gasoline and crude oil, natural gas, and other hazardous products. While it is considered the safest way to transport them, we can still run into trouble if we damage one while excavating. Of course, damaging any underground utility is serious, be it a water main, sewer line, telecommunications cable, or electrical cable. But hitting a high-pressure natural gas or petroleum pipeline, that can be deadly. That's why today, we're going to see excavation best practices in action. From calling 811 and following the one-call process, to white lining, interpreting utility markings, excavating safely, and learning how to respond if something doesn't go as planned. You'll also see experienced excavators train me on how to operate equipment and teach me the proper techniques for crossing a pipeline. Luckily, I'm a fast learner. So come on, let's get started and go meet the crew. Here in Casey, Illinois, family-owned company Bowen Enterprises Incorporated has been a leading pipeline maintenance service provider since 1987.
Hey, John.
Hey, Bo.
Good to see you.
Good to see you. You got taller.
Well, and a little bit wider, unfortunately.
Yeah.
Bo here is their operations manager, and he'll be the one showing me the ropes on today's adventure into excavation best practices.
So where are we going today?
Well, we have several crews out and about today working on different projects. They're all within various stages of excavation, and we're going to take you to a site where we haven't even broken ground yet, so we're going to start right from the beginning.
So we might find some worms for fishing.
We could.
All right. I'm right behind you.
All right.
So you got that backhoe fired up for me?
Sounds like you're pretty excited about that.
Oh, it's a kid in a candy store. Are you kidding? There you go. Okay. What's cooking here? There's no equipment, no people. You're playing a trick on me, aren't you?
Not quite, but before we start any excavation, we're going to have to do what we call white lining, and white line the area for
baseball.
No, but right now we're going to put out some stakes and some paint at our proposed excavation site to show everybody else where we intend to dig.
Need some help?
I do.
Ah, yeah, you're supposed to say no. Where do you get these flags? Like the little flag store?
Yeah, a little flag store, online catalog. So you ready to white line then?
I was born ready to white line, Bo.
Yeah.
So,
well, white lining is actually pretty easy to do. What we got going on today, we're going to take a drill rig and we're going to go from here and put a fiber optic cable from right here go underneath the utilities right here and come up on the other side over there in the yard.
Okay, this is for the cable TV and
Yeah.
computer and all that stuff.
So we're going to mark out where we're going to put our drilling machine right here.
Mm-hmm.
About a 10 by 10 area. We're going to make it a little bit bigger so we have a little bit of freedom to move here. But
Okay. Do you always do the flags before you do the white line?
yeah, a lot of times I do. Once you put your paint down, it's kind of more permanent. So basically, we're just going to spray paint the white lines on both sides of this and kind of box it in a little bit.
Did you hold on?
I got them. There you go.
Oh, look at that. I should probably move then.
Yeah.
It's the first time I've ever painted dirt.
First time for everything.
Yeah.
Pretty simple, right?
Yeah.
Well, next we have to make a one call.
A what?
A one call.
What's that?
It is one of the best practices that excavators follow to reduce the risk of accidentally damaging an underground utility. We're going to dial 811 to let everybody know that we have a planned excavation here.
Is that nationwide?
Nationwide.
No
Any
kidding.
phone. Yeah.
I had no idea.
Well, calling 811 is possibly the single most important step in this process.
More important than me on a backhoe?
Unbelievably, yes.
So you just dial 811 on any phone?
Any phone. Matter of fact, I'm going to let you use my phone, and you're going to call in our 811 request.
No kidding. Okay,
Yeah.
I'll make the call.
811.
811, okay.
Hi, this is Megan. How can I help you?
Well, we want to dig a hole, and we're in a field between the corn and a light blue house.
Turns out you need a couple of simple bits of information when making your call to 811 or your State One call center's 1-800 number.
We're backhoeing.
No, we're directional drilling.
We're directional drilling.
First, you need to be ready with the exact location of your dig site, the type of work you'll be doing, and your start date. You need to make the call to 811 at least 2 full business days before you want to start digging. A few states require a call 3 or more business days before excavating, so make sure you know your state's requirements.
All right. We'll make sure that facility operators with underground utilities near your project are notified to come and mark. Please keep your one-call ticket verification number in case you need to call us back if someone fails to respond and mark their lines, or if the markings become disturbed or worn away during your project. All right?
Thank you very much for making it really easy. It's really common sense, isn't it? Just dial 811 before you do any digging, and you won't get the shock of your life or remove somebody's cable system.
We just want everyone to be safe and protect the utilities underground.
Well, you do that. You do that well. Thank you.
Thank you.
Easy peasy.
Yep. Some states even accept online dig requests so they can get their information through the web.
Yeah, that's pretty cool.
I learned from Bo that for larger jobs involving multiple excavators, a separate one-call ticket is needed for every excavator on the job site. So everyone needs to make their own call to 811. Excavators should keep their one-call ticket number and the names and phone numbers of the utility companies at the job site. Also, for large or complicated jobs, the one-call center can help facilitate a pre-excavation meeting between the excavator and facility operators if requested. Requesting a pre-planning meeting is essential if the excavation requires the interruption of a utility service. These meetings help improve communication between the parties and reduce the likelihood of utility damage.
I've noticed you've got these markers. What are they for?
Federal regulations require that one of these pipeline markers be at every road, railroad, and water crossing for energy pipelines.
So, if you already know where the pipeline's buried, why bother with the 811 call?
This marker just tells us there's a line in the area. What it doesn't tell us is how deep the line is. We need for the pipeline companies and all the other utilities to come out and accurately locate their pipelines so we'll have a better idea exactly where they're at.
So it also tells you who the operator is and their emergency number, right? It tells you to call 811. We did that, all right? What's next?
Now we wait.
Oh, how long?
Well, in this state, we have to wait 48 hours.
Do I have to wait right here for 48 hours?
I didn't bring a sleeping bag.
No, I've got something else for you to do. I'm going to take you to another job site now, so maybe you can get your hands dirty there.
All right, boss, I'm right behind you. So, Bo, what are we doing here? What are
going
all the
on?
different colors for?
This is what it looks like after we validate 1-1 and the utilities have responded by marking their facilities.
So each color represents one of those utilities.
That's exactly right. Out here we've got a few different colors, but orange would be for communication, red would be for electric.
Well, that makes sense, doesn't it?
Yeah.
Sure.
Pink for temporary survey markers, yellow for petroleum or gas.
Okay.
And you know what white means?
Surrender.
No, white lining.
Okay.
Blue for water, green for sewer.
Okay, yeah, because the algae and alligators, yeah.
That makes sense. The purple is for reclaimed water or irrigation. So that's all your colors for different utilities.
Is that universal? Is that nationwide?
Yeah, this is the universal color code for utilities. So you can see where we've got some of these same colors out here, where the yellow is obviously marking out a petroleum pipeline or a gas pipeline here. In this case, it's Marathon Pipeline. Then they've got out some temporary survey markers. With the pink, we've got our white lining coming across here where we're going to install a telephone line. We got some orange and we got some blue over there. So we've got some water, then we got a communications line running over there too. If there's utilities that aren't involved in our excavation, they can write okay or no in their color out off to the side of our excavation so we know they've been here and they're clear of our excavation.
But what if they're standing on the wrong side of the no? It'll look like it says on.
It could. It gets kind of tricky that way sometimes, but no, it's usually pretty clear.
I just thought I'd mention it.
Yeah.
All right.
Not every utility will mark no or okay at the site. Some utilities will notify the excavator by email, phone, or fax that they are not involved.
Should we put the guys to work?
Yeah, matter of fact, they're working right now. They're going through pre-excavation activities here, verifying that all the utilities that said that they would be here and marked have marked. And if they're not here, then we'd have to call 811 again and say we had a non-response and go through the process again. Okay, so what we're going to do is go right into our job site review. These guys have done some documentation and taken some pictures of our markings and things. Keith, you're here with Marathon Pipeline, or I guess we're going to be crossing your line today. So we're going to be digging inside the temporary markers, these pink ones here. That is inside what they call the tolerance zone.
In most states, the tolerance zone includes the width of the utility plus 18 or 24 inches on either side of the underground facility. Check with the One Call Center for the requirements in your state.
So we're going to have to teach you the joys of hand digging and vacuum excavation since we're inside the tolerance zone.
Oh, I can't wait. That's why I got my gloves.
This runs your boom up and down. Raises it up and down there.
Okay.
The tolerance zone serves as a buffer of protection around the underground utilities. State law requires that excavators hand dig or vacuum excavate within the tolerance zone. Mechanical equipment should only be used if a utility representative is present and has given their approval. Most underground utility lines are marked by trained professionals, but the excavator is always the second line of defense. If you find an unmarked or inaccurately marked facility, you should stop excavation and call 811 and the utility owner. If the planned excavation continues past the life of a one-call ticket, you should contact the One Call Center to refresh or extend the ticket.
Well, that's pretty impressive. Probably could have been a little faster with a backhoe, though, don't you think?
Well, it could have been, except we were operating inside the tolerance zone, and we can't use a backhoe inside the tolerance zone.
Tolerance zone, the TZ.
Yeah. We're going to the backhoe next, and you'll be able to operate a backhoe real soon.
All right.
To assist the excavator, the pipeline representative will use the line-finding equipment and probe bars to confirm the exact location and depth of the pipeline prior to and during excavation.
You need somebody to show you how to work that thing? What are you doing here? This hole is a lot bigger than the other one.
It is. Yeah, here we've got a small water line that's crossing below our pipeline. We actually used 2 observers to help Jimmy to locate where the pipe was. Once we exposed it, they helped to keep him off of the pipe.
So they're watching as the bucket's moving around?
That's correct. You know, anytime there's an excavation occurring within 50 feet of a Marathon pipeline, a Marathon representative must be there to cover that dig. There are a number of things that we have to watch out for, not only to keep the excavator away from the pipeline and comply with the state law for a tolerance zone, but also to work with the observers. The observer that works with the backhoe operator, their purpose is literally to do the hand digging as necessary to expose the pipe, and then working with them to make certain that we get the excavation completed safely. We typically maintain a 24-inch clearance all the way around the pipe, above, below, and either side. That keeps the power equipment away from the pipe. That's primarily what's going to damage the facility.
Well, my next question is, what's the pipe made of?
The pipe's made of carbon steel.
So if you ding it, is there any forgiveness?
Any kind of scarring, gouging, or denting over time, flexing and working of that metal, it fatigues and can fail.
If an excavator causes what seems to be only minor damage to a pipeline or other underground facility, he should stop work immediately and contact the utility operator. Even a minor scrape or dent to a pipeline or the protective coating on the pipe may cause corrosion to begin and lead to a future leak. The utility company will inspect the damage and make any needed repairs before you continue excavating.
What happens if it starts leaking?
If it starts leaking, you need to call 911, and I need to call our operations center to shut down this high-pressure pipeline immediately.
If damage to an energy pipeline results in a release of any gas or liquid, federal law requires the excavator to immediately call 911 and the utility operator. Excavators are encouraged to cooperate with local emergency responders and other utility companies that could be affected during the emergency situation. In many states, excavation to make emergency repairs or restore service may begin immediately, but excavators should call 811 and the utility operator prior to excavation or as soon as practical.
So what are they doing with the railroad ties? They look like railroad ties.
Yeah, they're skids, we call them, John.
Oh, okay.
Anytime that we expose a span of pipe more than 10 feet, we need to support that span so that the stress load of the pipe is not just hanging on the pipe itself. So they're structuring that such that it'll support the pipe in a way that won't let it sag. We'll take the cribbing out after we've put sandbags or other support methods that's acceptable to Marathon in place, and we'll pull those out, and then we can start the backfill process. It's interesting too that you might note the foreign pipeline below us there is crossing us at a perpendicular angle. That's a necessary piece of this. If it goes at a long angle, it becomes more of a possibility for damage to occur while excavating. So it needs to cross at a right angle to our pipeline, and it needs to have 24 inches of clearance between the top of that foreign pipe and the bottom of ours. That needs to be maintained. And during the backfill piece, we will put some tape in there, some caution tape.
When caution tape is used, it's placed underground just above the buried utility. The tape alerts excavators that they are digging right on top of a utility.
So when you're refilling the hole, will somebody be down there with shovels doing the delicate work? Or are you just dropping all the dirt right on top of everything?
No, we're going to dip it in a bucket at a time and bring the sides up, bring it up, compacting it, continue to get dirt underneath the pipe, and to bring the compaction to about what it is or was before we did the excavation. That'll bring the support level of the pipe where it needs to be. Then once we get about 18 inches of cover on the pipe itself, then we can push the rest of it in and do the final cleanup of the site. Well, John, we've come a long way in this project here. We're down to the point where we're backfilling, and we've used what we would call select backfill. Select meaning that it doesn't have any sharp rocks, there's no large clods that would, over time, compromise the coating of the pipeline.
The best.
The best stuff we have. And at this point, really, if you would like to spend some time on the backhoe and put some dirt backfill in here, we would love to have you give it a shot.
I'd enjoy that.
Awesome. Well, have at it. Good luck.
All right, Keith.
Let's go get it.
All right.
You've been looking for this all day.
I sure have. Up with the right.
Start with your right, now follow through with your left.
Oh boy, okay. There you go. There you go. That's right there. That's all I wanted. I think everyone else has gone home.
That's great.
Hi-ho, 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 hi-ho. Now, let's see. Throttles here. Buckets. So to work we go. Let's pick that up. Now that was fun. But I think I should probably leave it to the professionals. Hey, speak of the devil. Bo, what's next? Good morning, Keith.
Oh, hi, John.
Morning.
Good morning, Bo.
So you got a hole and you got some machines. I'm figuring that one has something to do with the other.
Well, John, this is really a good one to see because directional drilling comes with its own specs for safe digging.
That's right. Any company that wants to do something other than a conventional excavation has to seek permission from Marathon Pipeline to do that. They have to present a plan to us. As the responsible person on site for Marathon, I have to make sure that the utility crosses us at a 90-degree angle or as close to that as possible, and also maintains the correct depth, which would be 4 feet below our pipeline. And that depth needs to be maintained from the time they enter our right-of-way on one side of the pipe until they exit the right-of-way on the other side. This fellow over here has a line finder, depth finder, that's going to be able to verify where the head is and what its depth is.
I think I saw Wile E. Coyote use a machine like that once.
Hopefully it wasn't to bore a hole through a cliff that he fell through later.
For a boring or directional drilling project, the pipeline crossing area must be exposed to visually confirm that the newly installed utility is at least 4 feet below the pipeline.
Hey, Tom.
Yeah, Bill.
You want to give John a ride on this thing?
Oh, absolutely. There, I'll show John.
Ready to go now. As a reminder, utility operators should be notified if the actual placement of the new facility differs from the planned placement.
Good job.
Well, that was fun. Thanks, everybody, for allowing me to play with your toys. And I realize they're not toys because this is a dangerous job and so many different ways to dig a hole. I had no idea. And I've learned that there's only one way to dig safely, and that's by calling 811 before any excavation job. Oh, you guys all have family, I'm sure, and I bet you they're very thankful that you're walking in the door every day safe and sound. And there's so many reasons to take those extra steps for safety. And thanks for all you do. And Bo, thanks for the exciting time out here.
Thanks for all your help.
Like so many jobs in America, this one comes with an extra set of responsibilities that can affect us all. An accident can mean personal injury to a crew member, tragedy for a family, loss of important services to a community, environmental impact from a pipeline release, massive fines for a violator, and all kinds of other nasty stuff. Following the excavation best practices helps to protect you, your co-workers, and our vital underground infrastructure. Calling 811 is the easy part. Using a backhoe? That might take a little more practice.
We take pride in our work, and there's a lot that goes into doing it right.
Our underground utilities are as important as they are potentially dangerous.
Public safety and interruption of services is the key and primary concern.
We want to keep the employees and the citizens safe. We want the job to be done in a safe manner without damage to utilities underground.
We have a shared responsibility to know what's below when we start a project, and we want to make sure that that project's safe for everybody.
We all know that digging safely around our underground infrastructure is a shared responsibility. Facility operators, locators, and excavators are all in this together and have a role to play in the prevention of damage or a serious accident. If any of these stakeholders fail to meet these responsibilities, the damage prevention process will be compromised. Damaging a buried utility can impact important services, as well as public safety and the safety of your crew. So even if you've excavated on a site previously, never make the mistake of thinking that you remember where the lines are buried. Old marks from a previous job and photographs of the location when it was last marked don't cut it. Pre-mark your intended dig site in white. Usually flags or water-soluble spray paint is best. The solution is simple. Depending on your state law, make a free call to 811 at least 2 to 3 days before you plan to dig to ensure that facility operators accurately locate and mark their facilities. That's the first step to safer digging. Always call 811. Here's how it works. 811 is our national one-call number, connecting you with your local one-call center, no matter where you're located in the country. The one-call center is your conduit to communication with all registered facility operators in the area. In some complex digging situations, a call center can even arrange an in-person meeting between the excavator and the facility operator to discuss the underground infrastructure. At the call center, helpful operators will ask you for relevant information about your digging project.
Thank you for calling 811. This call is being recorded. My name is Mary. How may I help you?
At a minimum, be prepared with the following information: the exact location of your dig site, the type of work you'll be doing, and your start date.
Address or street you are working on?
Main Street between 1st and 3rd. We're on the north side of the property, and I will pre-mark in white where I'm going to be digging.
Be as clear and exact as possible in your answers, and always confirm the information.
And when are you planning on starting the work there?
We're digging next Thursday.
Okay, so the area should be marked by Tuesday. Let me verify your information, and then please be ready to take down your ticket number.
The call center will issue a dig ticket, detailing which companies will be notified to mark the approximate location of their facilities.
That is correct. All right. I've already listed the facility operators that will be notified. Now, do you have any questions?
Nope, I'm set.
It is extremely important that excavators review the information associated with their locate request to make sure it is submitted correctly to the facility operators. Inaccurate information could cause delays, failed responses, or even potential damages. Now, some one-call centers even accept latitude, longitude, or GPS coordinates. The more precise your information, the better. Many one-call centers also offer online dig requests. These electronic or e-tickets allow excavators to submit their information at their convenience. Always be sure to maintain your request ticket number. The dig ticket, whether generated online or by your call to 811, is soon transmitted to facility operators, who will send out locators to mark the underground lines at your dig site.
What I'll do is give Steve, our locator for that area, a call and have him come out and verify that.
Depending on state law, this process takes between 2 and 3 business days. This is the second step to safer digging. Always wait the required amount of time. Though the laws vary by state, you typically need to call 811 at least 2 to 3 business days before any digging project in order to give each facility operator the time to respond and mark their lines. It is the facility operator and locator's responsibility to respond to locate requests as prescribed by law and in a timely manner. This is the foundation for step number 3 of safer digging: locate accurately. Facility operators should keep accurate records of underground facility locations, be members of their local one-call center for efficient communication and response, and accurately locate and mark underground facilities at excavation sites. When a locator responds to your job site, they'll be looking for your proposed excavation site, which should be marked in white, as well as being detailed in your dig ticket description. Locators use a variety of markings to communicate what is buried underground at your dig site using the following color code. Red marks your electric power lines and lighting cables and conduits. Orange marks your communication, cable TV, alarm or signal cables. Yellow marks your gas, oil, steam, and petroleum. Purple marks your reclaimed water, irrigation, and slurry lines. Blue is your potable water. Green marks sewer and drain lines. And pink is a color used for temporary survey markings. White is always the color used by the excavator to designate the proposed excavation site. If the dig area is free of buried lines, the locator will mark the site with an OK or No along with the company name, either with a flag or painted on the ground near your dig site. Once the required waiting time has lapsed, check all of the marks. And if it appears that a utility has not been marked and you've not been otherwise notified, call 811 again to help expedite a response and to record the discrepancy. This brings us to steps number 4 and 5. respect the marks, and dig carefully. When carefully planning your dig, be mindful of the marks and required tolerance zones. The tolerance zone is the width of an underground utility, plus a specified tolerance distance on both sides of that utility, generally between 18 and 24 inches, depending on state law. Never use mechanized equipment within the tolerance zone, but rather utilize hand or vacuum digging or other non-invasive equipment to determine the exact location of the utilities within the area, and take extra care to avoid damage and personal injury. With today's modern mechanized equipment, care and calculations are more important than ever. Backhoe excavations specifically are known to cause over 1 in 4 utility damages. Trenchless technology like underground boring or horizontal directional drilling has become a popular approach with its minimal surface disruption. But extra care should be taken to monitor and expose nearby utilities, and always include back ream radius in your safe distance calculations. Potholing is an important method for identifying the horizontal and vertical location of buried facilities, and should be utilized when open cut excavation is taking place within the tolerance zone, or at intervals along the boring route for trenchless operations. In congested areas where several utilities are crisscrossing or in close proximity to each other, locating accurately becomes more difficult and potholing is highly advised. No matter what equipment or expertise is being employed on a dig job, always remember step 5, dig carefully. Different digging environments present their own challenges, and all stakeholders in the damage prevention process have to be highly adaptive and extra careful. From rural and agriculture projects to high-density urban work, underground utilities need to be marked and protected. But even when observing the 5 steps to safer digging, minor damage can occur. A slight nick with a shovel, a little cut when hand trenching, or maybe your excavation might expose an existing problem. Either way, report any damage immediately by calling 811 or the facility operator directly. Even a small nick without signs of leakage now can become a serious problem with time, corrosion, or if underground root systems change. Report it now. If the damage causes an emergency, immediately call 911. Take reasonable steps to ensure public safety and notify the facility operator. Calling 811 before you dig is an essential first step to safer digging. So plan ahead. Make it a standard part of your process. By waiting the required amount of time and having your dig site marked accurately for all underground utilities, respecting those marks and digging safely, you'll be doing your part to avoid interruptions to important services, being held responsible for costly repairs, as well as preventing potential injuries or deaths. When we all commit to these essential 5 steps to safer digging and maintaining a high standard for damage prevention, we can go to work knowing we are keeping our crews and the public safer. For more information on safe digging, visit call811.com.
Vacuum excavation, also called soft excavation, is a means of soil extraction through vacuum, using pressurized water or air for loosening soil. Vacuum excavation is a viable, efficient means of soil removal with less ground disturbance, potentially lower costs, enhanced safety factors, and greater protection for underground utilities. You may hear terms like keyholing, potholing, or locating when people talk about vacuum excavation. Vacuum excavation is typically not done with sewer cleaning equipment, which uses much more water than vacuum excavation equipment and can cause surface undermining unless properly equipped. Always call your local one-call prior to excavation and comply with any federal, state, and local regulations. Misuse of this equipment can lead to property damage, serious injury, or even death, as well as damage to underground utilities. Familiarize yourself with your equipment and its proper operation. Read, understand, and follow all operating and safety manuals provided with your vacuum excavation equipment. Obtain replacements if any manual is missing. Understand the safety messages and symbols in the manual and on the equipment. This program will address the following areas: operator safety, equipment inspection, transporting equipment to and from the job site, before you start on the job site, operation and maintenance of vacuum excavation equipment, and finally, finishing the job. You can review and download helpful materials such as checklists and tailgate sheets at aem.org. Follow all applicable regulations for your region. Be sure to heed any location-specific restrictions placed on equipment and its use by the facility owner or operator. Symbols you must recognize and obey include this safety alert symbol that calls your attention to the possibility of personal injury or death. You must be alert and physically capable of operating the equipment. Never operate equipment while under the influence of drugs or alcohol. Wear all personal protective equipment specified in the operator's manual. In most vacuum excavation applications, the following personal protective equipment, or PPE, should be used: a hard hat. A high visibility shirt, vest, or jacket should be worn on every job site. Vacuum excavation equipment has moving parts and suction, so to avoid an entanglement hazard, wear work clothes that fit snugly and tie up long hair. Vacuum excavators or air excavators cause dust and can throw gravel, stones, or other debris, so be sure to always use safety glasses with side shields or goggles, and whenever necessary, a full face shield. Vacuum excavator job sites can be very noisy. Use hearing protection such as earmuffs or earplugs. Protect your body with garments that completely cover you and provide reasonable protection from the impact of rebounding or thrown object debris. Wear water-resistant clothing when operating water jet equipment. Wear cut-resistant gloves that provide water protection. Wear waterproof steel-toed boots with metatarsal guards. Shin guards are recommended. If excavating around electric lines, contact the energy company to de-energize the line. If the line cannot be de-energized, wear electrically insulated gloves and boots while on the job site. Wear respiration equipment appropriate for the job site. This may vary due to the chemicals used, materials being excavated, and the adequacy of fresh air available at the job location. For procedures using hydrovac excavation in the vicinity of electric distribution lines, see the E&USA Safe Practice Guide, Excavating with Hydrovacs in the Vicinity of an Underground Electric Plant. Before beginning any job, familiarize yourself with the equipment. Perform a walk-around to make sure the equipment is in proper working condition. Refer to your operator's manual for the manufacturer's recommended checks. Never go under any raised component unless it's properly supported according to the operator's manual. The component could fall and crush you. The manual will instruct you on the proper use of safety devices like lock valves, pins, or retaining arms. Inspect the hydraulic and water jet hoses according to the instructions in the operator's manual. Visually inspect for fluid leaks. If you must pressurize the system to find a leak, never use your hand to detect a leak, even if you're wearing gloves. If you suspect a leak but cannot see one, follow the instructions in the operator's manual for leak detection and repair. High-pressure fluid can be invisible and can be injected into the body through the skin. Serious injury or even death can result. If an accident occurs, get immediate treatment from a doctor familiar with this type of injury. Check that all scheduled maintenance has been performed, especially lubrication of rotating parts. Check the brakes and steering systems of the vacuum excavation equipment. Do not operate if the brakes or steering controls are not functioning properly. Check that the headlights, brake, and signal lights are clean, visible, and in good working condition. Warning lights must be clean and working. Inspect all tires for damage and recommended inflation, and make sure the lug nuts are tight. Make sure all equipment guards and shields are in place. Check for holes, tears, openings, or worn areas that could allow objects or fluids to pass through. If worn or damaged, they must be replaced. Use only replacement components specified by the manufacturer. Other parts may not be suitable for your vacuum excavation equipment and could fail or reduce performance. When moving the vacuum excavation equipment to and from the job site, the following precautions must be taken. Make sure the tow vehicle is rated to handle the weight and size of the vacuum excavator, along with full water or spoil tanks. Consider the effects of water sloshing when sizing the tow vehicle. Drivers must comply with all federal, state, and local regulations. A commercial driver's license may be required. When transporting hazardous materials, ensure the equipment is approved for such use. Follow all applicable regulations in your region. It's important to identify buried utility lines. Contact your local one-call or one-call referral number to have underground utilities located before working. Also, contact any utilities that do not participate in the one-call service. One call may not identify private utilities, sewer lines, or retired utility lines, so you may need to hire a professional locating company to locate private utilities. Do not proceed with vacuum excavation until locating has been completed and all items are marked. Note: some states allow the use of vacuum excavation without locates. Inspect the job site perimeter for evidence of underground hazards, such as utility signs and other underground facility notices, gas or water meters, junction boxes, drop boxes, light poles, manhole covers, sunken ground, or old locate markings. Inspect the worksite for surface and overhead hazards, such as overhead power lines, overhead tree limbs, on-surface structures, utility poles or other structures that may need to be supported, manholes, inspection plates, signs, and trenches and drop-offs. Ensure that no part of the equipment or boom gets closer than 20 feet to the power line. It's recommended to have a spotter to help ensure a safe distance is maintained. If exposing an underground utility, contact the utility owner to determine precautions that need to be taken based on materials used, the age of materials, and potential hazards associated with those materials. Buried hazardous materials may require additional safety equipment or treatment. Consult an expert in these matters. If working on a roadway, follow required temporary traffic control measures. Use job site controls, such as cones and barricade tape, to limit bystanders from entering potentially hazardous areas and proximity to machinery. When preparing the equipment for operation, place wheel chocks under the wheels. A potential combustible dust hazard may require additional safety measures. Consult your manufacturer for their recommendations. To dissipate static electricity, ground the equipment per the manufacturer's recommended procedure. When working in confined spaces, be sure to take precautions. Test the atmosphere for oxygen. Follow all facility, state, and OSHA confined space regulations. Note: a permit may be required. If a permit is required for space entry, follow OSHA CFR 1910.145-146. The safe exposure of underground facilities within the tolerance zone is essential to damage prevention. Site conditions may make the use of hand tools to expose underground facilities difficult or impractical. Vacuum excavation, when used properly, is an efficient, safe, and effective alternative to hand digging within the designated underground facility tolerance zone. However, many underground facility owners and operators have specific criteria for safe excavation and exposure practices around their facilities. When exposing utilities, the equipment should only be operated by a worker trained and experienced in its operation. They must be familiar with the practices which provide appropriate levels of worker and public safety, and should know the proper procedures to prevent damage to buried facilities. Only use equipment designed for excavation work. Some sewer equipment is not designed for excavation work and should never be used for this purpose. Always review and follow the operator's manual and other safety information for proper application and intended use. Familiarize yourself with the different types of tubes, hoses, fittings and clamps, pressure lines, and vacuum lines approved for your equipment. Verify the functionality of all safety relief valves. Always hold a vacuum hose end away from your body or anyone else. A major hazard associated with this type of equipment is suction. Use the proper hose end attachment. It only takes seconds to kill or injure a person. Remember, you're dealing with water or air at very high pressure. Follow all safety instructions to prevent damage to yourself, your coworkers, and utilities. Pressurized air and water wands can cut or injure, so be sure to keep the nozzle away from your body. Specific wands and nozzles are designed for use with this type of excavation equipment, so only use accessories approved for use with your particular equipment. Use caution when working within the tolerance zone. Keep air and water wands in motion at all times while excavating to minimize the risk of damaging the utility. Using a rotary nozzle reduces the risk of damage to underground facilities. Never insert the nozzle into the subsoil while excavating within the located utility's tolerance zone. Keep the pressure wand nozzle at least 8 inches away from the underground facility and/or subsoil. Use recommended water volumes. Normal application is under 10 GPM. To help avoid damage, use as low a pressure as needed to break up the soil. When pressurized water wands are used, the maximum recommended water pressure to be used with a straight-tip nozzle is 2,500 psi. The maximum recommended water pressure to be used with a rotary nozzle during excavation is 3,000 psi. All pressure measurements are to be monitored using a pressure gauge mounted on the excavation machine. If water is heated, reduce the pressure accordingly. When vacuum excavating, avoid using excess water volume or pressure to prevent erosion or undermining of roadways, utility poles, or other structures. If damage occurs to underground facilities or coatings while excavating, the facility owner or operator must be contacted immediately. When excavation work is complete, the job is still far from being done. All tools, hoses, tubes, and other items must be removed from the work site and placed in their proper storage location. Use the unit's water system or other source to wash down any tubes, hoses, and any other areas that may have mud or rocks on them. If the excavation must be left open and unattended, it must either be barricaded or covered with materials of adequate load rating. If the hole is to be filled in, the final surface must be flat and free of material that could cause a hazard. Before transporting the equipment, perform a pre-trip inspection to ensure all hoses, tubes, clamps, and other items are secure. Follow all state and local regulations for proper disposal of spoils. Review the guidelines for safe transport of sloshing materials. Dump and clean the debris container at the end of the work shift and between jobs at an approved dumping site to prevent cross-contamination. At the dump site, ensure that the unit is placed on level, stable ground with no overhead obstructions. Follow the manufacturer's instructions to decant fluids and open the container door. Make sure the area around the rear of the unit is clear of personnel when opening and closing the door, and raising and lowering the debris container. Only open the door when the container is in the lowered position. Never move equipment with the debris container elevated. Doing so could damage the equipment or cause the unit to tip over. Always use body and door safety props when cleaning or working around the unit. The debris container may be considered a confined space. When working inside the debris container, take the necessary precautions. Before leaving your equipment, follow the manufacturer's shutdown procedures. Always place the transmission in the park position, set the parking brake, shut off the engine, remove the key, and block the wheels. This will prevent the vacuum excavation equipment from moving unexpectedly or from use by unauthorized persons. If you're done for the day or changing sites, drain all the water out of the water tanks, lines, and water pump. If the ambient temperature might be below freezing, follow the manufacturer's recommended procedures. Ensure that hoses, pipes, and other equipment are properly stored on the unit. If the equipment will be shut down for an extended period of time, disconnect the battery. Compare mileage and hour meter readings to the maintenance schedule to see if maintenance is required. Thank you for watching this program on safety practices for vacuum excavation equipment. This important information is intended to help reduce the potential for serious personal injury, downtime, machinery repair, and damage to property and underground utilities. Make safety procedures an important part of every workday. Awareness and attention to safety will not only help protect you,
commonly referred to as HDD, is a surface-to-surface installation technique that is comprised of 3 primary stages, including pilot bore, reaming, and product pipe installation. This method of construction is typically used to install pipelines in areas not amenable for open-cut construction, including major water bodies, wide or busy highways, railroads, environmentally sensitive areas, and urban environments. During construction, no disruption occurs to any feature being crossed by the HDD installation. With proper design and good HDD construction practices, the HDD method allows for the installation of pipelines with no impacts to the crossing features. Limited workspace is established on both sides of the crossing to house the necessary drilling equipment and to facilitate product pipe string fabrication. These sites are cleared and leveled to facilitate drilling operations. Silt fencing and other erosion control measures are placed around the site. If necessary, sound curtains are erected at the drilling sites for noise mitigation. The drill rig and power unit is placed into position on the drill alignment. A drill pipe skid is positioned next to the drill rig. A small entry pit, approximately 5 to 6 feet deep, is excavated at the front of the drill rig to collect drilling fluid returns. A separation plant, holding tanks, and drilling fluid pumps are set up and plumbed with the drill rig. A control cabin is placed immediately next to the drill rig. This cabin houses the controls used to control the drill rig and track the drill bit location. Drilling of the pilot bore commences by pushing and rotating drill pipe connected to the drill bit along a predetermined path from the drill rig entry location towards the exit side located on the far side of the crossing. A mixture of water and bentonite clay, referred to as drilling fluids, is continuously pumped through the drill pipe to the cutting tools where it mixes with the soil or bedrock cuttings. This mixture flows back to the drill rig location, carrying the entrained cuttings, where it is transferred to a separation plant to remove the cuttings and recycle the fluid component for reuse downhole. Aside from assisting in removal of cuttings, the drilling fluids also serve to stabilize the bore, cool the cutting tools, and lubricate the pipe string. As the pilot bore is advanced, a tracking system is used to locate the position and orientation of the drill bit. Steering adjustments are completed by the drill rig operator to maintain the design alignment. When the drill bit exits the ground surface on the far side of the crossing, the pilot bore stage of the installation process is complete. The pilot bore is typically enlarged by pulling reaming tools of successively larger diameter from the exit location back towards the drill rig location. Depending upon the diameter of the product pipe, multiple passes with reamers of increasing diameter may be required to incrementally enlarge the pilot bore to its final diameter. Upon completion of the full reaming passes, the condition of the HDD bore is assessed by completing what is known as a swab pass. The pass consists of pushing or pulling a slightly smaller diameter reamer through the fully reamed bore from start to finish. The diameter of the swab pass is typically smaller than the full reamed diameter, but greater than the diameter of the product pipe to be installed. Like the pilot bore drilling process, Drilling fluids are continuously pumped through the drill pipe to the cutting tools, where it mixes and entrains the soil or bedrock cuttings into the fluid. This fluid aids in removal of the cuttings, continues to stabilize the bore, cool the cutting tools, and lubricates the pipe string. Sections of product pipe are transported and positioned at the HDD exit location. The pipe sections are then welded together to form a completed pipe string. Coatings are applied to welds and tests are completed to ensure proper coating application. The product pipe string is then pressure tested with water, drained, and placed on pipe rollers. Pipe rollers and cranes, or side booms, are used to assist the pullback process. The rollers and slings used in conjunction with the lifting equipment not only provide support for the fully fabricated pipe string, but also help reduce the amount of friction acting on the section of pipe above ground, and reducing the overall amount of force required to pull the product pipe into the bore. The rollers and equipment are also used to position the product pipe to match the angle of the bore where the pipe enters the ground surface. Upon completion of the reaming process, and once the product pipe string is completely fabricated and welds X-rayed and coated, the final stage of the installation process, pullback, can begin. The pullback process consists of pulling the fabricated product pipe from the pipe entry location towards the drill rig. The HDD installation is complete when the product pipe reaches the drill rig location. Final checks and surveys are completed on the installed product pipe. With the completion of the pullback operations, the drilling equipment is demobilized and the work sites are restored to pre-existing conditions.
Hi, my name's Marco Carr. I'll be your host for this training program. I've worked for large and small companies on construction sites like these around the country. I wish I had the time to tell you how often I've been involved in injury and fatality investigations related to excavation safety. What I can tell you is that a lot of what you're going to hear today, whether it's OSHA requirements, company policies, or my recommendations, are based on actual tragic facts. Things like rigging failures, trench collapses, electrocutions happen quite frequently. People die on construction sites every day. A friend of mine lost his brother when a retaining wall collapsed. The vast majority of these injuries and fatalities are preventable, but it takes a great deal of pre-planning, communication, and training to ensure that everybody can go home safely at the end of the day. First, let's talk about three important definitions. An excavation is any man-made cut, cavity, trench, or depression formed by the removal of earth or soil. That means either mechanical or hand removal. You may have heard the terms excavation and trench used interchangeably, but there is a difference. A trench is an excavation that's deeper than it is wide, usually not wider than 15 feet. Bottom line is that nearly all trenches are dangerous if not protected, due to the fact that they're narrow and you can get trapped. Some excavations, however, especially on large building sites, may only be dangerous near the slopes. It's important to know the difference and to always be on your toes. You've probably heard the term competent person. I'm the designated competent person on this job site. It's my job to identify existing hazards or to predict hazards that may occur in the excavation or in the surrounding areas. Every day I have to take a close look at the conditions of the site to make sure that all the protective systems are keeping workers like you safe. I've got to determine whether working conditions are unsanitary or hazardous to workers, and it's my duty to take prompt corrective measures to eliminate any danger. Basically, it's my job to make sure that you and your coworkers can do your jobs safely. Did you know that cave-ins are the leading cause of death in excavation work, and that collapses are 18 times more likely to result in death than common construction accidents? Cave-ins aren't the only dangers involved in excavation work, though. Other hazards include water accumulation, the collapse of nearby structures, and hazardous atmospheres produced by toxic gases in the soil. That's why if you ever think that there's a potential danger of a collapse or any other type of hazard, you must tell your supervisor, foreman, or the competent person immediately. I can't stress enough how important it is to speak up. With all these potential hazards looming on a job site, no one's going to get upset if you're being overly cautious. You could be saving someone's life, possibly your own.
An employee was installing a small diameter pipe in a trench 3 feet wide, 12 to 15 feet deep, and 90 feet long. The trench was not shored or sloped, nor was there a box or shield to protect the employee. Further, there was evidence of a previous cave-in. The employee apparently re-entered the trench, and a second cave-in occurred, burying him.
Since cave-ins are the most common and the deadliest hazard in excavation work, let's look at them a little more closely. When dirt is removed, the surrounding soil becomes unstable and gravity forces it to collapse. When soil or rock falls or slides into the excavation, the cave-in could entrap, bury, or otherwise injure and immobilize people working in the excavation. Most cave-ins occur in trenches 5 to 15 feet deep and occur suddenly with little or no warning. On average, about 1,000 trench collapses occur each year in the United States, and over 95% of injuries occur in trenches without any protective systems. Did you know that only 2 to 3 feet of soil can put enough pressure on your lungs to prevent you from breathing? In as little as 4 to 6 minutes without oxygen, you can sustain considerable brain damage. And within 10 minutes, well, it might just be too late. In fact, the chances of a trapped worker being killed can be as high as 50%. Trench work is serious work and can have serious consequences if it's not done correctly. Soil conditions can change and shift, so they must be constantly evaluated. There are certain factors that could change the surroundings of the site, making a cave-in more likely. For instance, it rained here last night, and water could potentially affect the state of the soil. So I constantly check the condition of the soil and of the surrounding site and evaluate any condition that may increase the likelihood of a collapse. If you're the designated competent person on site, that'll be your job too. But it's also important for every worker on site to know and recognize some of the most frequent problems and to communicate them immediately. Water is one factor that can increase the risk of a collapse. Other factors include temperature change, vibrations from heavy equipment. Even the surrounding load, like a spoil pile, can affect the conditions of the excavation. Also, a lot of the soil that we work in has been previously disturbed. Previously disturbed soil is different from soil that's never been excavated. It can contain backfill or other materials that can rapidly break away from native soils. Sometimes there are visible warning signs around the excavation that can be spotted before a cave-in occurs. And if you're aware of these warning signs, your chances of getting out before a collapse increase significantly. Some of these visible signs may include ground settlement or narrow cracks in sidewalls, slopes, or the surface next to the excavation. Flakes, pebbles, or clumps of soil may separate and fall into the excavation, or there may be changes or bulges in the wall slope. If you notice any of these signs, get out of the excavation immediately and get your coworkers out too. A life is too high a price to pay to overlook any one factor or warning sign. Cave-ins are possible, they can happen if you're not careful, but they can be prevented. And let's face it, preventative measures take a lot less time and effort than an emergency retrieval. There are different types of cave-ins that happen in various types of conditions. For instance, a spoil pile slide is probably the most common type of cave-in. It occurs when dirt is piled too close to the edge of a trench. A shear wall collapse occurs most frequently in clay or layered soils. Part or all of one side of the wall begins to crumble into the trench, along with the weight of the spoil pile. The height of the falling soil is added to the weight, generating a great deal of force. An average collapse of 2 to 3 yards of soil can weigh 4,000 to 6,000 pounds, or nearly the weight of a pickup truck. A lip slide may be an indicator of a potentially more hazardous collapse to come. A belly slough often occurs in areas near underground utilities or where running water is present. This type of slide occurs when softer soil weakens under the more stable soil. The collapse can be rapid and usually buries or traps the victim quickly. The resulting overhang makes rescue more dangerous and difficult as well. Telltale fracture lines often appear near the bottom wall of the trench before a belly slough occurs. Boiling and heaving and squeezing are two other types of soil conditions that need to be taken into consideration when working in a trench or excavation. Boiling is marked by an upward water flow into the bottom of the cut, creating a quick condition, like quicksand. Heaving and squeezing is a downward pressure created by the weight of surrounding soil or adjacent equipment that causes a bulge in the bottom of the cut. Both boiling and heaving and squeezing may contribute to or indicate a potential collapse, and both conditions can occur even when support systems have been properly installed. Your safety and the safety of your coworkers is the #1 reason why the right type of protective system is used for the soil that you're working in. But before you choose a protective system, you have to test the soil to determine what type it is. Now, not all dirt or soil is the same. Solid rock is most stable and sandy soil is the least stable. You've probably heard that soil falls into 4 types: solid rock and types A, B, and C soil. Let's talk a little bit about what these classifications mean. Solid rock, in most areas that I've seen it, requires explosives for removal, and it becomes a lot less stable when you blast it. In certain cases, you can scrape away at it with frost hooks or vibratory hammers. But for the most part, solid rock isn't something that we work in on a regular basis. Type A soil is stiff and cohesive without fractures or cracks. A few examples might be caliche, typically found in the southwest, or hardpan, also called glacial till. Now, you'll know this soil if you've worked in it. Hand digging is backbreaking. And if you've worked in these soils, you also know that their condition can change quickly. Caliche can be seamy, and hardpan turns to slop when it gets too wet. Now, it's important to keep in mind that no soil can be considered type A if it's fissured or cracked, or if it's subject to vibration of any type, or if it's been previously disturbed or has seeping water. If the soil is part of a sloped or layered system where the layers dip into the excavation on a slope of 4:1 or greater, the soil can't be considered type A either. These layers could slide off of each other, causing a collapse. The problem is it can be difficult to determine which way the layers run. Type C soil is the most granular, like sand or gravel. And type B is somewhere between types A and C, like subsoil or silty sand. Even some crushed or blasted rock could be classified as type B soil. Sometimes soil may have to be reclassified if the conditions affecting its original classification change in any way, such as with the addition of water from any source. Now, many times we're digging around existing utilities as well, which increases the potential for collapse and for changing soil conditions. This is especially true with bedding materials used for most utility installations. Now, there are some inherent problems in classifying soil as anything other than type C. You have to be careful because sometimes soil is layered. There may be a type B soil on the surface, but a few feet into the dig there might be a layer of type C soil. And how frequently do we find water on job sites? These conditions point to classification as type C. So soil should be treated as if it's type C unless proven otherwise. There are several ways to classify soil. Test bores taken before work begins provide a good indication in advance of the type of soils to expect, but you can't just rely on lab results. Out in the field, besides looking at the general excavation site and its surroundings, as the competent person, I have to perform a visual analysis of the soil itself. I check the composition of soil samples to see if the soil is granular or cohesive. I look for cracks and spalls in the sides of the excavation and around the adjacent surface area. I also check for existing utility lines and any other underground structures, and for any previously disturbed soil in or around the excavation. I also need to look for sources of vibration and surface water. Each one of these factors can affect the excavation stability and influence the type of protection needed before you get in. Manual tests must also be performed on soil before excavation begins, and there are a number of methods that can be used. Some of the methods test the cohesion of the soil or how well it sticks together, and other methods test the strength of the soil. The thumb penetration test is probably the easiest soil test. All you do is press your thumb firmly into the soil. If your thumb doesn't go any further than the length of your thumbnail, it's most likely a type B soil. If your thumb penetrates the full length of your thumb, then it's probably type C soil or very granular. The problem with this test is that it can be very subjective. When I need to document my test results, I usually use a pocket penetrometer because it gives a reading that's easily interpreted, and it's typically accepted in the engineering community. But even this device has its shortcomings. You have to try to avoid rocks and other particles that could influence the reading, and you don't want to test in an area where the soil's obviously been disturbed. It's important that the reading is taken in fresh samples, typically right from the spoil pile. You insert the shaft about 1/4 of an inch into the soil with smooth, constant force, and take the reading from the indicator ring here. The limited accuracy of manual tests is one reason why many contractors have a policy to simply classify everything as type C. This can be a costly and time-consuming policy to implement, but it definitely cuts down on the variables and the arguments about who classified what and why. I should probably also talk just a bit about documentation. While OSHA doesn't require that these visual and manual evaluations be documented, it's a good idea, especially on the off chance that something bad does happen on site. Many contractors use a daily inspection form like this one to document their safety efforts. Once you've finished performing visual and manual tests and you've established a soil type, then you can determine what type of protective system you'll need. If your company automatically assumes Type C, then that planning process has already begun. There are various types of trench protective systems to meet pretty much every type of soil condition. Protective systems protect workers from cave-ins, from material that could fall or roll from an excavation face or into an excavation, or from the collapse of adjacent structures. Protective systems are required in nearly all excavations. Now, selecting a protective system for an excavation depends on soil conditions, the depth of the trench, and environmental conditions surrounding the site. One thing that's for sure, though, a registered professional engineer must design protective systems for excavations any deeper than 20 feet, no exceptions. You can slope or bench an excavation, which means cutting away and angling the excavation face, or you can install support systems like trench boxes or shoring. When you slope an excavation, you cut the sides back to a safe angle using relatively smooth inclines. The safe angle used in sloping and benching, known as the maximum allowable slope, depends on the type of soil that's being excavated. For Type A soil, the maximum allowable slope is 3/4 to 1, or about 53 degrees. Type B soil is 1 to 1, or about 45 degrees. For Type C soil, the maximum allowable slope is 1.5 to 1, or 34 degrees. The maximum allowable slope varies for layered soils as well. Basically, as you can see, the more granular the soil, the more gradual the incline. Benching is similar to sloping, but instead of smooth inclines, you cut the sides of the trench wall back using a series of steps. Again, the angles for benching depend on the type of soil. One important thing to remember, though, is that you can't bench Type C soils. They just won't hold the bench properly, and they could collapse. Many times, trenches are in narrow places or roadways, so sloping and benching aren't options. In these situations, support systems like shoring or shielding are typically used. There may even be instances where you may have to combine sloping or benching with a support system. Shoring structures are typically made of metal or wood. They're designed to support the sides of a trench and prevent soil from caving in. They basically consist of plating held firmly in place with expandable braces. There are many types of shoring systems. Some of them are easy to install, and others require quite a bit of experience and engineering. Before wood or timber shoring is installed, proper sizing and spacing of the cross braces, uprights, and wales has to be established. The proper size and spacing of shoring components are determined based on the type of soil, the depth, the width of the trench, and how much space is actually needed between the cross braces to perform the work. Other types of shoring may include aluminum hydraulic systems, driven interlocking sheeting, soldier piles and lagging, pneumatic shoring, and screw jacks. Shoring systems have their advantages and disadvantages. For example, shoring can be custom tailored to the trench. It can be used in narrow confines and is typically easier to install around underground utilities. However, shoring requires a greater technical knowledge to be installed correctly, and portable shoring systems are typically not suitable for deeper excavations. Shielding structures, or trench boxes as they're often referred to, are placed inside trenches or excavations and are strong enough to protect workers in the event of a cave-in, so long as the workers are within the confines of the box.
I have experienced a trench cave-in where a brother union member and myself were in an excavation, and the trench caved in on the opposite side of the box, and luckily the person that I was with got into the box in time before he was crushed. The one suggestion that I would make to all members of all trades is training. Training is key. Training, training, training. Always come back. There's never too much safety that you can learn.
Shielding systems also have advantages and disadvantages. They're designed to be moved along a trench as the work progresses and can usually be installed faster and used in deeper trenches than portable shoring systems. But on the other hand, the size, weight, and bulk of a typical trench shield make transporting them to the work site as well as within the trench difficult. Whether you use shoring or shielding, it won't protect you if you aren't inside it. Remember, if the excavation is more than 20 feet deep, the entire excavation protective system has to be designed by a registered professional engineer. We can't just throw something together. I should also point out that manufactured systems like hydraulic shores and trench boxes come with what's called a tabulated data sheet. This sheet documents the acceptable design load for the specific device being used. For instance, a box might be designed for depths of up to 20 feet in a Type B soil, but it may only support depths of 15 feet in a Type C soil. Now, these sheets need to be kept on site for reference. Make sure that the serial numbers on the sheet match the numbers on the box, and never modify a system without written consent from the manufacturer. No matter how many years' experience we have in the field, most of us aren't structural engineers, and we can't change a protective system's design without their input.
Back in 1979, I was a laborer out of Providence, Rhode Island, Local 271. I was a top man watching for the safety of the people inside. Unknowingly, the earth around the outside of the trench box gave way. We fell about, I would say, into the earth 10 feet. It undermined from water outside the trench underground. And it caused just a washout, and we went down. The only thing that was showing was like half of my right arm. And that's how they knew where we were. Through the quick response of other laborers, they dug us out. And, you know, we were scratched up a little, a couple of cuts from shovels, but we were all right, thank God. We learned, if we ever were buried, not to panic, because naturally you're using up the oxygen that would be in your body under a stressful condition. My message is to work safe in and around these trench areas, around machinery. If they foresee a condition, report it immediately to their foreman out on the job site.
Even after testing soil and determining which protective system will be used, problems can still occur. That's because there are still many other safety and health issues that need to be taken into consideration before digging and throughout working in an excavation. Things like surface encumbrances, utility lines, hazardous atmospheres, fall protection, roadway safety, and water accumulation, just to name a few. That's why it's so important to have a competent person on the job site at all times. My job doesn't end with inspecting site conditions, testing soils, and determining which protective system to use. I also have to test for hazardous atmospheres, monitor water removal equipment, inspect and evaluate excavations before a shift begins and throughout the day. I have to reassess after any type of weather change or when there are nearby sources of vibration. I need to pay close attention to whether the walls of a trench begin to sag or crack, or if the bottom bulges or water seeps in, or if a spoil pile has changed size, location, or placement. I pretty much have to keep an eye on things all day long. And if I see any sign that a protective system might fail, or find any other indication of a possible cave-in, it's my responsibility to make sure that all workers are removed from the area and that they stay away until all the necessary precautions have been taken. Surface encumbrances are common on trenching and excavation job sites. When's the last time you worked in an area where there wasn't a tree, a telephone pole, or pavement nearby? Any surface encumbrance that can create a hazard must be removed or supported as necessary to safeguard workers. Excavation work can also threaten the stability of adjoining buildings, walls, sidewalks, and pavements. In these cases, support systems such as shoring, bracing, or underpinning must be installed to ensure the stability of these structures. Once again, this is probably a good time to get a structural engineer involved. Let's face it, when performing excavation work, there's always a chance that underground utilities exist. Digging into underground utility lines can cause hazards like fires, explosions, flooding, electrical shocks or arcs, and toxin inhalation, all of which can cause serious injury or even death. Before digging, your employer must contact the utility companies or the property owners to locate sewer, telephone, fuel, electric, water lines, and any other utilities. If any underground utility lines or other installations exist, They must be protected, supported, de-energized, or removed. And don't forget, utilities can be overhead as well. Always maintain a minimum of 10-foot separating distance from overhead power lines.
Mike, there's a broken pipe up there on the hill. Can you tell me a little bit about what happened there?
Well, we were ready to cut and cap it up on the top of the hill, and the water department said it was shut down. We put a whole ram through it. Ended up it wasn't shut down. We ended up filling up the entire area you see here that's been blasted out. About 100,000 gallons or so filled the area.
When working in a trench, you can't just jump into it and try to find a way to climb out later. There has to be a safe means of entry and exit for workers, like a ladder, stairway, ramp, or other safe means. You must be able to exit a trench quickly and within 25 feet of where you're working. It's also a good idea to make sure that there's at least one ladder per trench box so workers don't have to climb over or through spreaders to get out. Lifting equipment such as loader buckets and backhoe shovels are not safe means for entering and exiting a trench. If you use a ladder, it has to be inspected prior to use and it must be installed and secured properly. Ladders must also extend at least 3 feet above the landing surface. If you use structural ramps, a competent person must design them and you need to be able to walk upright up the ramp.
Two plumbers who had been working in a trench were being hoisted to street level in the bucket of an excavator. As the excavator operator started to swing, the bucket jerked, causing one employee to fall approximately 14 feet. The employee struck his head on the pipe in the trench, causing a fatal injury.
Remember that you're not the only one working on the site. There may be other workers operating equipment or machinery, and they may not always see you. Be sure to make eye contact with the operator of any type of heavy equipment to let them know that you're there. And avoid the sweep, reach, dump, or path of any machinery or equipment too. Likewise, don't stand under any loads handled by lifting or digging equipment, or near any vehicle being loaded or unloaded. If there's mobile equipment operating next to or at the edge of an excavation, use some type of warning system such as barricades, hand or mechanical signals, or stop logs to let the operator know where the edge is. I also make it a habit to wear my reflective safety gear whenever I'm working around heavy equipment. It makes it that much easier for the operator to see me. Again, this is a requirement that many contractors are instituting, and I think it's a great idea. Excavation and trenching operations are often conducted on roads and highways. When you're working on or near a highway, it's important that you wear reflective safety gear. You need to make yourself stand out as much as possible in a situation where there are drivers and heavy equipment operators around you. Make sure that you inspect your work area frequently and wherever possible minimize the effect of excavation operations on traffic, such as changes in traffic patterns. New traffic patterns can be confusing to drivers, which can make them dangerous for you and your coworkers. Don't ever turn your back on traffic. Make sure that you see them even if they don't see you. And never stand in an open traffic lane. Show pedestrians and motorists where you expect them to go, and give motorists enough time to respond. But have a buffer space prior to the work area, just in case. Think about how the weather conditions may affect visibility and stopping distance. Drivers have a harder time seeing in heavy rain or fog, and have a harder time stopping when it's snowing or sleeting. Make sure that there are enough warning devices such as cones or barrels on the roadways, and replace any damaged signs or devices that you see immediately. They're not going to be very effective if they're not visible. Everyone working on the site must have adequate training. Some states even require certification for flaggers or the use of police details for traffic control. But regardless of who's directing traffic, it's important that everyone know what their job is and where they should be. Perhaps most importantly, plan an escape route just in case an emergency does occur. Lifting and moving heavy loads with rigging cables and hooks are common operations on excavation sites, so it's important that safe rigging procedures are followed. Any rigging performed on site must be done under the supervision of a competent person who's experienced in rigging, and all rigging equipment must be inspected by a competent person prior to use. Chains used for lifting should be grade 80 or better and marked as such. And make sure that multi-leg cable slings and nylon slings are marked with their capacity as well. Never pull slings out from under a load with equipment. This can cause excessive abrasion. Remove damaged equipment immediately and notify your supervisor or the competent person that the equipment is unfit for use. Lastly, make sure that you're properly trained, and if you have a question, don't be afraid to ask. Most of the time, workers need to get from one side of the excavation to the other, so proper walkways must be provided. Any walkway that's 6 feet or more above a lower level should be equipped with guardrails to prevent falls. To avoid slip and fall accidents, make sure that all access and walking surfaces on equipment are oil and dirt free, and that slip-resistant finishes are maintained. Some areas may also require guardrails or tie-off on equipment for service personnel. All wells, pits, shafts, and remote excavations must be barricaded or covered and clearly marked so that workers don't fall in, and workers and materials should stay as far from the edge of the excavation as possible. Remember that many folks can be curious, especially kids. These barriers can help protect them as well. Another hazard to look for is loose rock, soil, stored materials, and equipment on the face of or near the excavation. These things can potentially fall or roll into the excavation or overload the edge and collapse the excavation walls. To prevent a spoil pile slide or possible trench collapse, scale the face of the excavation to remove any loose material and set up barricades to contain anything that might fall. Try to place spoil piles so that rainwater is diverted away from the excavation. And it's important to remember to keep everything, spoil, materials, and equipment at least 2 feet from the edge of the excavation. If there are workers that are higher on the slope of an excavation than other workers, workers on the lower level must be protected from falling, rolling, or sliding material or equipment. If you can't safely store the spoil on site, move it to a temporary site. The potential for atmospheric hazards can be found in many areas associated with excavation work. Potential atmospheric hazards include any atmosphere with less than 19.5% or more than 23.5% oxygen, sewer or natural gases, and hydrogen sulfide, typically found near landfills. Even the exhaust from machinery can cause the air to be hazardous. Trenches, pipes, manholes, catch basins, and foundation excavations with limited air movement can contain toxic or explosive atmospheres. And atmospheric hazards are especially dangerous in trenches because of the lack of air circulation. Before you enter an excavation that's more than 4 feet deep or any confined space, the competent person must test the air for oxygen deficiency and any other air hazards. Air monitoring must be repeated as often as necessary, sometimes even continuously, to ensure that the air remains safe for workers. Respiratory protection or mechanical ventilation and emergency rescue equipment must be readily available when working in these types of conditions. If you're working on an excavation site with potential atmospheric hazards, you will need emergency rescue equipment. This includes breathing apparatus, safety harness and line, or a basket stretcher. If you enter a deep and confined footing excavation, you must wear a harness with a lifeline, and the lifeline must be separate from any line used to handle materials. Don't ever attempt to rescue unless you're properly trained to do so. Otherwise, you could end up a victim yourself. Over 50% of confined space fatalities are would-be rescuers. Air isn't the only thing that can be contaminated on an excavation site. Soils can be contaminated too. It's good practice to perform a soil evaluation to make sure that the soil is not contaminated. Unfortunately, this isn't always done. So it may be up to you to catch any visible signs of contamination in the soil. Keep an eye out for oil sheens on standing water or chemical odors or staining of soil. Dead or distressed vegetation or buried containers, drums, and creosoted timbers will be indicators of contaminated soils. If you notice any of these warning signs, bring them to the attention of your supervisor immediately. Water accumulation in an excavation also makes for a dangerous situation for a number of reasons. Water softens the soil, which can lead to a cave-in. It makes getting out of an excavation in an emergency even more difficult for workers. Water accumulation in an excavation also creates electrical and drowning hazards. You should never work in an excavation with standing water or where water is accumulating unless adequate protections have been taken. Protections against water accumulation include installing special support or shield systems, using safety harnesses and lifelines, or removing the water with pumping equipment. Your site's competent person must monitor procedures against water accumulation to make sure that they're effective. Workers are not permitted in any excavation below the base or footing of a foundation or a retaining wall that's likely to be a danger to them. The only exceptions are when a support system, like shoring or shielding, is installed, or when the excavation is performed in stable rock, or when a registered professional engineer has determined that the excavation activity will not affect the structure nor pose a threat to the workers. Even after all precautions are taken and every safe work practice is carried out, you and every worker on site must be prepared in case the worst does happen. And you must be able to think and react quickly should an emergency occur. Emergencies typically come about quickly and without warning in excavation operations, and they can sometimes very easily result in injury or death. Excavation and trenching emergencies are not limited to just cave-ins. Material, equipment, or workers could fall into an excavation. A worker could succumb to a hazardous atmosphere, come in contact with an electrical line, or be struck or crushed by vehicles or equipment. What if the protective system fails? Would you know what to do in the event of an emergency? Luckily today, these guys are just practicing, but tomorrow it could be the real deal. And so the faster you react, the faster they can react. When you start working on a job site, make sure that you know the location of the nearest landline phone and any phone numbers that you might have to dial in your area. Remember that some places don't use 911 as their emergency number, and cell phones, they don't work on every job site. Your company should have an emergency action plan, and it must be communicated to every single worker. If you're not sure what the emergency action plan is for your site, don't be afraid to ask questions. Your knowledge could help prevent serious injury or even death. Trench and excavation retrievals are extremely dangerous operations. Additional collapses could occur, or utilities could collapse into unsupported trenches. Attempting to use equipment to dig a trapped worker out could result in decapitation or other very serious injuries. Trapped workers are frightened and can become frantic, and would-be rescuers react in much the same way. This puts the victims in even greater danger, and the rescuers could become victims themselves. This is why emergency retrieval should only be executed by people who are properly trained and equipped to perform them. So don't ever enter the trench during an emergency without proper training. You can do your part to help, though. Keep calm, secure the site prior to the rescue team's arrival. Shut down all equipment. Move materials and tools away from the trench, and account for all workers on site. But once the emergency personnel arrive on the scene, back up and let them do their jobs. Rubberneckers can get in the way of trained rescue personnel, and that could cost valuable seconds, which could be the difference between life and death.
We have been activated once in central Massachusetts for an incident where a gentleman was working in a construction site, putting in a foundation, happened to have a very high water table in the area, and the gentleman got stuck in the mud approximately up to his waist or a little bit higher. The contractors worked approximately 2.5 hours prior to notifying the local fire department that there was actually an emergency on scene. Once the local fire department got activated, they arrived on scene and they activated our technical rescue team. We responded with all our members, and once we arrived on scene, it took us approximately a half hour to remove the victim from the mud. Some of the injuries we could have expected would have been like the crushing syndrome. Had it been like chest level, obviously the patient wouldn't have been able to expand his lungs or her lungs at the time. So we have to allow for that during the extrication so we don't have a sudden onslaught of blood rushing through the body where the body was compressed. People should follow the regulations and laws that are required of them, such as using a trench box when it's required. If the trench does get deep enough that it requires to be engineered, then they should have an engineer do it. If they follow most of the regulations, then they really shouldn't have a need for our team to respond, which is the way we would rather see it.
Sometimes you can stop an emergency before it even occurs. When in doubt, get out. If you see anything about the excavation that looks unsafe or dangerous, get yourself and your coworkers to a safe place as quickly as possible. Notify your competent person and let him or her know of your concerns. We're trained to deal with these types of situations and can determine the next steps to take to ensure your safety. Remember, working smarter means working safer, and that makes everybody's job a lot easier.
Today we're talking about one of the most dangerous hazards on any job site, being in the line of fire. I'm going to walk you through the key things you need to know to stay safe and avoid becoming a line of fire casualty. This is important stuff, so I need you to stay focused. Lives depend on it. The line of fire, simply put, refers to the path of a moving or flying object that could strike you if something goes wrong. It's that invisible zone around any piece of equipment, material, or tool that, if you're standing in it, puts you at serious risk of injury or even becoming fatal. Think about it when that forklift is transferring heavy pallets, or the crane is swinging a load overhead, or the power tool is kicking back. There's a clear line of fire that you need to avoid at all costs. One slip-up, one moment of distraction, and you could end up directly in the path of that dangerous object. The consequences can be devastating, from broken bones to traumatic brain injuries to crushing fatalities. It's the kind of thing that changes lives in an instant, and it's 100% preventable if we all do our part. So where are the biggest lines of fire hazards on our job sites? A few key areas to be extra alert. Around any operating heavy equipment like cranes, forklifts, loaders. Anywhere overhead work is being done, like on scaffolding or roofs. When using powder-actuated tools or other high-powered equipment. Anytime materials or objects are being lifted, hoisted, or transported. In between two pieces of moving equipment or machinery. Those are the danger zones where you really need to be heads up and hyper-aware of your surroundings. Don't get complacent. Even for a second, that's when accidents happen. All right, so how do we keep ourselves and our crews safe from these lines of fire hazards? First, always be aware of your surroundings. Avoid that invisible danger zone as much as possible, and if you have to work near it, make sure you've got a clear escape path planned. Second, follow all the established safety protocols to the letter, things like maintaining a safe distance, using spotters, and double-checking loads and rigging. Don't take shortcuts, even if you think you've done it a million times. And third, speak up if you ever see something unsafe happening. Don't be afraid to call a timeout or flag a hazard. Your voice could save a life. We're all in this together, and it takes all of us watching out for one another. At the end of the day, line of fire incidents are some of the most devastating but also the most preventable accidents we see on construction sites. It's on all of us to stay alert, follow the rules, and look out for each other. Remember, you're the experts in this work, so trust your instincts and don't ever put yourself in harm's way. With the right mindset and the right safety practices, we can keep this crew 100% safe, start to finish, so please stay safe on the job.
Powered mobile equipment plays a key role in the construction industry. However, the construction industry has experienced numerous fatal incidents where workers have been crushed by vehicles or mobile equipment. Many of these incidents did not involve a spotter and/or occurred as a result of inadequate planning or communication. When utilized in appropriate situations, the use of a properly trained and competent spotter can play a significant role in preventing workplace damage, injuries, and fatalities. So we have an understanding that the use of spotters is advantageous to the safe execution of work with heavy equipment. Are they used at all times? Not necessarily. But here are some common scenarios encountered on construction sites when spotters should be used. Spotters should be utilized when navigating with materials, working in tight or congested areas to assist in monitoring the operator's blind spots, working around overhead utilities or structures, excavating around buried facilities, and on sites congested with heavy traffic and/or ground personnel. While every construction site will present different scenarios, it's important to recognize the site-specific hazards and identify when the use of a spotter will help eliminate or control those hazards. So does just having a spotter make things safe? No, not really. A spotter contributes to a safe work site only if they are properly trained and understand their function. They must recognize the equipment requirements and limitations and be able to give clear direction to operators. Not everyone can be an effective spotter, and recognizing some of the requirements needed is essential in selecting the right person to do the job. A spotter needs to possess the following skills. Must have a strong understanding of the task, good vision and be able to judge distances with accuracy, clearly understand all communication protocols, including signals to be used to direct equipment operators, be fit for duty, including the strength and ability to stand for longer periods of time, and may need to be able to walk significant distances. They must remain diligent and alert in recognizing changing conditions and hazards. Understand the need for and maintain the care and appropriate personal protective equipment needed for the job. Possess a responsible attitude in maintaining a safe work environment for themselves, the operator, and their work site. Employers need to recognize these requirements, and workers tasked with spotting duties need to demonstrate these skills. The wrong person tasked to spot equipment can result in significant damage, injury, or even death. We've identified the requirements and expectations needed of a suitable spotter. However, before any work can begin, a hazard assessment must be conducted. This process must include all personnel involved in the task at hand and is required to be reevaluated and updated as the task or day progresses. While every task and site will pose their own hazards, some general hazards to consider as it pertains to the spotter's role can be applicable in all operations. Consider ground conditions. Is it smooth and dry, or is it slippery and uneven? Is there a slip or trip potential for the spotter? Do the ground conditions present a potential rollover concern for equipment? What about hazards above? Are there overhead power lines, structures, or work areas present where the spotter or equipment will be working? Are there buried utilities in the area, and have these been identified and marked? If spotting equipment during excavation work, all utilities must be located and positively identified. Are adequate ground disturbance clearances being maintained, and do you know what the clearances for mechanical excavation are? Is the work area congested, or does it present restricted movement for the equipment? With pivoting equipment such as excavators, how much room does the equipment have to operate considering their swing radius? Are other workers in the area of the mobile equipment? What are the blind spots of the particular equipment, and what are the safe positions for the spotter to be to both direct the operator and stay clear of blind spots or pinch points? Is the spotter positioning safe in the event of operator error, mechanical failure, or equipment upset? Does everyone involved fully understand the communication protocols or signals to be used and the method of communication established? Are two-way radios to be used in combination with visual signals, or are the spotter and operator relying solely upon visual communication and signals? These are some of the most common and critical questions to consider when completing your hazard assessment. You will never control a hazard that you do not identify. It's possible that one of the most critical controls to consider after assessing the hazards begins with spotter positioning. By ensuring the spotter is clear of blind spots, in constant visual contact with the operator, and on the best ground conditions available, the hazards for personal harm to the spotter can be greatly reduced. This position must always provide a safe emergency route for the spotter in the event of equipment upset, mechanical failure, or operator error. It's also critical to ensure the spotter is clearly visible to the operator both in their line of sight and clearly identified with the use of Class II high-visibility vest and possibly arm gauntlets. General positioning should always adhere to the following practices. Never stand directly in front of or directly behind any equipment. Always avoid pinch or crush points. When hoisting materials or equipment, never walk or stand underneath a load under any circumstance. Stay clear of equipment blind spots. If you can't see the operator, they can't see you. Ensure footing is stable and don't stand in positions or on ground that possess slipping hazards or presents potential to collapse, such as at the edge of an excavation. When possible, position yourself in an area that minimizes movement. This reduces the likelihood of slips and trips and also helps the operator know where you are at all times. If an operator ever loses sight of the spotter, they must immediately cease operation and re-establish line of sight with the spotter. Prior to beginning work and as part of the hazard assessment, the spotter and operator should conduct a full walk-around of the equipment. This walk-around provides an opportune time to communicate blind spots or machine-specific requirements. This communication gives the spotter more information to safely guide the operator. Whenever equipment must travel along a route, always plan ahead by inspecting the desired path and minimize the distance of travel, especially when the equipment is in reverse. While two-way radios provide an effective method of communication, they may not always be available, which emphasizes the fact that the spotter and operator must always maintain visual contact with one another. This stands true even when two-way radios are being used. All signals to be used must be clearly understood by the operator, spotter, and the personnel on the construction site. As a spotter, you will need to approach equipment. However, you need to execute this in a particular manner. Before entering the swing radius or safe distance areas, establish eye contact with the operator and communicate your intent to approach using hand signals or with two-way radio. Wait until the operator acknowledges your communication, places the blade, buckets, forks, etc. on the ground, and places engine in neutral or turns off the equipment. Only after this has been completed and the operator signals you to approach may you do so. Now it's time to take a look at what these signals are and how to perform them. These signals are applicable for all equipment and vehicles. When signaling, ensure all signals are clear, deliberate, and conducted at a speed the operator can clearly interpret. To direct an operator to proceed slowly, raise both arms, then bend repeatedly toward head and chest, and then extend. Always face your palms in the direction of desired travel. To direct an operator to turn, point one arm to indicate the direction to turn. Bend the opposite arm repeatedly toward your head to indicate continued turning. Often when signaling, you will be assisting the operator to get close to another object. To assist in identifying the stopping point for the operator, face palms forward with hands above head indicating the distance remaining. As the vehicle or equipment nears the stopping point, bring elbows and hands together, reflecting the distance remaining. Always keep in mind that distance signaling is a coarse measurement and equipment may need more room to come to a complete stop. To stop movement of equipment or vehicle, cross both arms above the head. Any situation requiring equipment or vehicles to stop in an emergency should be demonstrated as follows. Start with hands clasped overhead. Then extend downward repeatedly until the vehicle stops. To direct equipment or vehicles out of the area, point at the driver and gain eye contact. Turn body while maintaining contact and extend arms in the desired direction of travel. In all cases, the operator must take direction and guidance from the spotter. In situations where there may be need for more than one spotter, such as maneuvering equipment in tight areas, only one designated spotter must give operator direction. Conflicting direction to an operator can be disastrous. The only time another spotter should give direction directly to the operator is in the event the emergency stop command must be given. We reviewed the general signals earlier, but spotting for certain equipment such as an excavator or backhoe does require understanding other signals. To direct pivoting equipment to swing, simply raise the appropriate arm with the hand extended in the direction the equipment is to swing. Equipment with buckets can be directed to open by extending your arm at a 45-degree angle and with hand flat, pointed at the ground, straighten out. To signal to close the bucket, with arm and hand extended at 45 degrees, cusp hand and bend towards the body. To signal for the operator to bring dipper or stick in, with arm out at a 45-degree angle, bend at the elbow towards the waist. To signal for the operator to move the dipper or stick out, reverse the in signal. Spotters should always be utilized when completing simple lifts or the moving of materials. Many lifts and the hoisting of materials may require the use of trained and competent riggers, as hoisting materials and equipment is a high-risk task and must be treated with great care and adequate hazard control. When moving material, ensure the spotter and operator plan to inspect the route prior to movement. Remember to watch for overhead power lines and other utilities, ensuring that the appropriate clearances are maintained. If power lines are present, these should be marked with goalposts, clearly identifying the required clearances. On congested, restricted, or highly active work sites, traffic control personnel or devices may be required prior to moving material and equipment. To signal for the operator to hoist material or equipment, with forearm vertical, forefinger pointing up, move hand in a small horizontal circle. To lower a load, with arm extended downward, forefinger pointing down, move hand in a small horizontal circle. Working around overhead power lines is a critical task that poses increased risk of injury or death due to electrocution, fire, or explosion due to contact, equipment damages, and power or service outages. The spotter plays a critical role in these operations. A spotter must always have a clear view of the power line and operator and have the ability to immediately inform operator of danger. The use of an air horn is often employed in this situation. The spotter must also remain within the safe limits of approach as defined by occupational health and safety regulations and not encroach upon these distances. In Alberta, a minimum distance of 7 meters clearance to power lines is required. However, many companies may have more stringent distances in their policies. If ever work is required to be completed within the safe limit of approach, there are significant additional controls that must be put in place prior to work commencing, including contacting the power line owner. We've spent a lot of time discussing the spotter, their requirements, and the need to communicate well with operators. But safe spotting operations also require a lot from the operator. In order for an operator to work safely with the spotter, they need to follow some guidelines as well. While mandatory in all situations, operators need to ensure mirrors, windows, and visual aids such as backup cameras are clean and clear of dirt, mud, and in cold weather, defrosted. They need to follow the spotter's direction and ensure the spotter is in the correct location to monitor active blind spots at all times. If communication, signals, or directions are unclear, it is the operator's responsibility to stop the equipment to clarify or reassess the situation. They must not operate the equipment independently or disregard their spotter. If they are to lose visual contact with their spotter, they are required to stop operations and reestablish visual contact. Operators must always operate their equipment at a safe and appropriate speed, regardless of whether or not they are working with a spotter. At times, things can go wrong despite efforts to prevent injuries to personnel or damage to equipment and property. If there is an emergency, all equipment should be shut down. Your site-specific emergency response plan, or ERP, will specify the procedures, which may vary slightly from site to site. Not knowing where to muster can put you and others at significant and unnecessary risk. You need to know your responsibilities and where your muster point is located. The use of powered mobile equipment isn't going to disappear from construction sites, but the harm associated to people, property, and the environment can. Through completing appropriate hazard assessments, putting the associated controls in place, and by utilizing competent and trained spotters when necessary, can greatly reduce the risk to life.
Today's safety meeting topic is Stop Accidents Before They Stop You, and Your Stop Work Authority. We are taking time in our safety meeting today to emphasize our obligation to stop accidents before they stop you if you think the job you are doing or are about to do is unsafe. We will cover our Stop Work Authority initiative, review recent achievements in health and safety and incident trends, discuss what we can do differently to ensure we stop accidents before they stop you, and generally work safely. And lastly, we'll look at the path forward and what we can all do better to improve our participation in our safety program. It is imperative that all employees understand that working safe is a condition of employment here at W.C. Striegel. All employees have the responsibility and obligation to themselves and coworkers to stop accidents before they stop you, and to use your stop work authority when hazards or at-risk behaviors are present. We must protect the safety of ourselves, our coworkers, our customers, and the public at large above all else. Our philosophy is that the health and welfare of people are among the most important considerations in any undertaking. The protection of company assets and the environment are also primary concerns. But no job is so important that we cannot take the time to do it properly and therefore complete it safely. This philosophy better enables us to deliver the highest quality services to companies we contract to. It is our policy to provide a place of employment which is free from recognized hazards, to provide accident prevention training programs and systems, and to comply with applicable local, national, and international regulations. Understanding that safety, accident prevention, and environmental protection are individual operational responsibilities, this policy requires all employees at all levels to be responsible for the prevention of job-related injuries and illnesses, property damage, and environmental accidents through the use of their good judgment and the diligent, consistent application of company guidelines and procedures. Employee safety performance will always be a major consideration in decisions affecting promotion, salary considerations, and continued employment. The company's collective safety performance will be the measure of success of this policy. Daily safety meetings like this one, where this video is being watched and discussed, have been mandated company-wide for supervisor education and improved employee safety education. We continue to monitor and improve our 500-plus page safety manual and our HES, standing for Health, Environment, and Safety, employee field manual, which has been distributed. Additional copies are available through our safety coordinator at the Safety Center. A safety education matrix is in place that is to be used to identify the education required for any position you hold within the company. A calendar was established to assist scheduling of safety education sessions. The calendar identifies daily safety meeting topics that provide more in-depth, job-specific tailgate meetings where the topic is related to the task on the job being done. New daily topics for safety meetings and tailgate meetings are continually being developed and distributed to assist supervisors in facilitating their daily meetings. Most of our injuries involve the hand and/or fingers. Other than avoiding pinch points and line of fire areas, selecting and wearing the proper hand protection is your best defense from injury. Remember, one glove does not provide adequate protection for all hazards, such as heat, chemical, sharp objects, etc. Another is twisted ankles. We should continue to cover slips, trips, and falls on our JSAs, but we can also be more productive when we see someone walking backward or carrying a load that obstructs their vision, etc. Remember, you can stop accidents before they stop you, just by speaking up and using your stop work authority. What can we do differently? Before the job, we can plan our work to be sure that we have the job properly set up, that we have the right tools, and that they're in good condition, and that we have the right personnel with the right experience and knowledge to do the job safely. If we don't have things set up to complete the job task safely, we must stop the job. During the job, we must intervene when conditions change or one of us is about to do something unsafe. When the job turns south on us, or things just aren't cooperating and we're getting frustrated, that's the time to stop the job, even for a short time, to make sure that everyone is clear on any changes and is in the right frame of mind to continue. After the job is stopped, we should capture the information by putting our thoughts on what happened on a near-miss report. That can help us to prevent the same thing from happening again when we share it with the rest of the company. And, if in doubt at any time, stop the job until you're sure it's safe to proceed. We need your help. You are in the best position to stop accidents before they stop you. Stand up and take control of the job. It's your safety that's on the line. We need to learn from the experiences of those who have used stop work authority. We will document the situation and actions of those who've stopped the job so others can learn from the same experience. Again, we need your help. After you've reported stopping the job, capture the information, preferably on a near-miss report, and if you haven't already, notify your supervisor. Every individual must have the courage to use stop work authority to stop an unsafe act from proceeding until they're satisfied it's safe. What examples can you share when you stopped the job either at work or off the job? What prompted you to stop the job? And how would you approach someone and tell them they're in harm's way? We will continue to engage and promote stop work authority in order to stop accidents before they stop you. Leadership will be initiating conversations to reinforce the culture and to ensure that employees feel empowered to stop accidents before they stop you, without feeling intimidated or fearful of being reprimanded for bringing up the subject. So, what will you do when you believe a job is not safe? There is only one acceptable answer, and that is, stop the job. You have the authority and the obligation to stop the job until you are satisfied it is safe to proceed. Employees have the responsibility and the authority to shut down any job or operation that, in their opinion, is unsafe. This statement makes shutting down the job your obligation as our employee. We also require that notification of the unsafe situation must be communicated to management immediately. So, your first obligation is to yourself and to your coworkers to shut down the unsafe job. Then, your responsibility is to notify your supervisor or another person on the management team of the situation so that corrective action may be taken. In the future, you have a decision to make. What are you willing to tolerate? And when would you take action? What prevents you from stopping the job? Too many people are afraid to rock the boat, so to speak. But we need to know the barriers keeping you from stopping an unsafe job or action so that we can address them and learn how to improve our training. So please share this information. You can do this right after the video with your supervisor, with the safety coordinator, or any other member of management. Thank you for participating and have a safe day. In the future, you have a decision to make. What are you willing to tolerate? And when would you take action? What prevents you from...
Hello again, it's the Safety Brief. I'm Dan Clark. This is where we talk about health and safety hazards in today's demanding industrial and construction work sites. You forgot your earplugs. What? You forgot your earplugs. What? 60% of workers face some kind of hearing loss hazard at work, but this problem can be easily fixed with proper hearing protection. It's not such a wild claim that loud sound will cause hearing damage, but let's drill down and look at how sound can sneak up on you and cause damage. Sound is measured in decibels, and hearing damage can happen as low as 85 dB. Well, what does that mean? A normal conversation is about 55 dB. A hairdryer, 70 dB. A lawnmower, now we're getting into potential hearing damage, 90 dB. The vuvuzela horn at a soccer match can be 108 dB. A jet plane takeoff, 140 dB. At that threshold of 85 dB, the length of exposure impacts the damage. For example, at 88 dB, it would take 4 hours to cause damage. At 98 dB, a half an hour. It increases quickly at a logarithmic rate. I wear hearing protection when I mow the lawn. I don't have a 4-hour lawn job, but I still wear it. There are 3 types of noise that can damage hearing. 1, continuous. Now, this is the ongoing sound, a piece of machinery that runs constantly. People learn to tune these things out, which can be dangerous since they won't realize they're putting themselves at risk. 2, intermittent sound. It occurs for a few seconds every once in a while. An example, a power tool. People think that because the length of exposure is short, they aren't at risk, but a power saw is 110 dB, and that spike in sound can mean hearing damage. 3, impulsive sound. This is a blast or loud explosion lasting for a second or less, like nail guns or most firearms. They're in the extreme range of sound above 100 dB, where even short exposure can cause damage. What can a boss, manager, or company owner do? 1, reduce the noise levels. There are new campaigns to isolate workers from machinery with sound walls around the machinery. 2, provide hearing protection. Earplugs come in many designs and are cheap, but workers say they often block out too much sound, and in extreme sound cases, they may not provide enough protection. Earmuffs, some say, are more comfortable than earplugs, and they can provide the most protection. Some advanced earmuffs can even amplify voices, so employees can still hear each other. They are more expensive, though, and earmuffs do look a little goofy. 3, conduct annual hearing tests. This demonstrates to employees that the company values hearing safety. It can also flush out who already has hearing damage, so extra steps can be taken to prevent more damage. Well, that's all for this episode. When it comes to hearing, keep your workers and yourself safe.
If a fire breaks out, you may be tempted to grab the nearest portable fire extinguisher to try and put it out. But before you do, make sure you know the following. Are you certain the fire is not too large to be put out with the portable fire extinguisher? Is the extinguisher you have the right type for that fire, or the right size? And what is the proper sequence of steps to take when using a portable fire extinguisher? Unless you know the answer to all of these questions, you should not attempt to extinguish a fire. Otherwise, your actions could result in extensive property damage as well as personal injury or even death. The Occupational Safety and Health Administration, or OSHA, regulates portable fire extinguisher use in the workplace. While fire extinguishers are addressed in many different sections of the OSHA regulations, the primary OSHA standards regarding fire extinguishers in construction are found in 1926.150, and the primary standards for general industry are found in 1910.157. When portable fire extinguishers are provided for employee use in the workplace, OSHA requires employers to provide their employees with an educational program covering the principles of fire extinguisher use. Employees must also be provided with information about the hazards associated with incipient or early stage firefighting. In addition, actual hands-on training in the use of fire extinguishers must be provided to those employees designated to use an extinguisher as part of their job, such as fire brigade members and fire watches. This tutorial covers considerations for selecting the proper fire extinguisher for the type of fire you are facing. It also explains the acronym PASS, which can help you remember the 4 sequential steps to operate a portable extinguisher. And we also discuss some do's and don'ts to remember anytime you use a portable fire extinguisher. The first rule to remember is that portable fire extinguishers are not intended to be used for fighting large fires. They are intended only for use on what are known as incipient stage fires. Those are defined as a fire that is in its initial or beginning stage, can be handled safely with the portable extinguisher, and does not require the use of special personal protective equipment such as bunker gear or a respirator. When faced with a large fire, immediately evacuate the area and alert others. You should also evacuate the area anytime you are not comfortable with using an extinguisher. There are many different types of portable fire extinguishers, and using the wrong kind on a fire means you may not be able to extinguish it safely and effectively. For example, most everyone knows that oil and water don't mix, and that is the reason you would not want to use an extinguisher that sprays water on burning liquids. That can actually make the flame spread. Some fire extinguishers are intended for use on a single type or class of fire material, while others are designed for use on a combination of 2 or more classes of fires. Just check the label on your extinguishers to know which type or types of fire they are intended to extinguish. Class A rated fire extinguishers will be marked with symbols similar to those pictured here. These extinguishers are suitable to use on ordinary combustible materials such as wood, paper or cardboard, dry vegetation, and some plastics. Basically, most anything that leaves an ash after it burns is a Class A fire material. Class A fire extinguishers often contain water that is sprayed on the fire. So again, as a reminder, do not use water to extinguish a flammable liquid fire, nor do you want to use water to extinguish an electrical fire for obvious reasons. Class B rated fire extinguishers will be marked with symbols similar to those pictured here. These extinguishers are suitable for use on fires involving flammable liquids such as gasoline and diesel, solvents, and oil or grease. CO2 extinguishers, which contain gaseous carbon dioxide, displace oxygen so the fire cannot continue to burn. These extinguishers are often used on Class B fire materials. While they are effective, the CO2 can displace the oxygen inside of a small enclosed space, so only use these extinguishers where there is plenty of natural ventilation. Also, the horn-shaped nozzle where the gas is discharged can become extremely cold enough to cause frostbite, in fact. So use caution when handling one of these type extinguishers. A Class C rating, signified by symbols like those pictured here, mean the fire extinguisher can be used on a fire near or involving energized electrical equipment. This designation is typically seen on combination type fire extinguishers that are suitable for use on other types of fire too. Class D rated fire extinguishers will be marked with symbols similar to those pictured here. These extinguishers are intended to be used on fires involving combustible metals that actually burn, such as magnesium, sodium, or potassium. Class K fire extinguishers, which are the newest type on the market, are marked with symbols similar to those pictured here. These specialty extinguishers are designed for use on kitchen fires, specifically those involving deep fryers which contain animal-based oils or fat, as well as vegetable oils. Some fire extinguishers are rated for use on only one class of fire material, such as A, or B, or D. However, most extinguishers are designed for use on 2 or more classes of fire material. For example, this foam extinguisher is rated for use on fires involving Class A and B fire materials, while this CO2 extinguisher is suitable for use on Class B and C fires. But the most prevalent type extinguisher found in most workplaces are combination ABC extinguishers. These commonly contain a dry powder that smother out a fire, much like you would with a blanket, and can be used to extinguish fires involving ordinary combustible materials, flammable liquids, and electrical equipment. So, check the labels of your portable fire extinguishers in your workplace so you will know what type or types of fire they are rated to extinguish. One more thing to consider when you use a portable fire extinguisher is its size. A relatively small portable fire extinguisher, like this dry chemical extinguisher designated as a 5ABC, will only last about 6 to 10 seconds before empty. A larger extinguisher, like a 20ABC, will last somewhere around 25 to 35 seconds before it is emptied. While that is certainly a longer time, most people are surprised at how fast even a large fire extinguisher can be completely emptied. There are 4 basic steps to use most portable fire extinguishers. However, people often panic when they see a fire and forget exactly what to do. To help you remember the 4 basic steps of fire extinguisher use, just remember PASS, or PASS. The P stands for pull the pin. Stand several feet back from the fire while holding the extinguisher in one hand, and then insert your finger into the round end of the retainer pin and firmly pull. And don't worry, the thin plastic band that holds the retainer pin in place on most extinguishers will break relatively easy. The second step is to aim the nozzle or discharge hose at the base of the fire. The idea is to apply the fire extinguishing media towards the material that is burning and not at the flames that may be leaping up high. Step 3 is to squeeze the handle to discharge the fire extinguisher. If you let go of the handle, the discharge will stop, and if you squeeze it again, it will resume. The fourth and final step is to sweep from side to side as you slowly approach the fire. This allows you to cover all of the burning material and not just that located at the center of the fire. In review, the 4 steps of the PASS method are: pull the pin out of the handle, aim at the base of the fire, squeeze the handle, and sweep from side to side. Here are some important things to keep in mind in case you are going to try and extinguish a fire. The first is to never get yourself in a position where you could be trapped should the fire spread. Always maintain a clear path away to the nearest exit or other safe area and evacuate immediately if the flames, heat, or smoke seem to be getting out of control. And once you have extinguished the fire, keep an eye out for flare-ups. Sometimes the fire continues to smolder beneath the burnt debris, and it is not uncommon for a fire to reignite several minutes later. Fire extinguishing media, such as water or foam, can collect on the floor around a fire and cause you to slip, as can ash or liquids from containers that might have burst during a fire. So don't run, just walk in a controlled manner so you don't slip and fall. Also keep an eye out for any boxes, pallets, or other materials that are placed on shelves or stacked near the fire area, as they could become unstable from fire damage and fall over on you. And always turn in any extinguisher that has had its pin pulled out of the handle to be checked. Even if you did not squeeze the handle, you may have broken the internal seal that maintains the pressure inside of the extinguisher. So play it safe and get it checked out. So in review, take some time to familiarize yourself with the types and sizes of portable fire extinguishers around your workplace, as well as any you may have at home or in your vehicles. And if you do discover a fire and are going to try to extinguish it, notify someone else about the fire, and then remember PASS: pull, aim, squeeze, and sweep. These are the 4 basic steps to use a portable fire extinguisher. Also, keep in mind the importance of maintaining awareness of your surroundings so you don't become trapped or injured while attempting to extinguish a fire. Finally, never attempt to use a fire extinguisher if you are not comfortable doing so. Instead, you should evacuate immediately and go to a safe area in accordance with your organization's emergency action plan. If you have any questions at all about the use of a portable fire extinguisher, please talk to your safety representative or supervisor at work. You can also contact the safety professionals at OSHA Training Services.
Capana was a contract worker performing maintenance at a New Jersey refinery.
We actually had pulled out of the refinery and were called back in to do one last job, which was to demolish an old pumping station. We were told that it was a water pumping station. It was not a water line, it was a crude oil line, in fact. We tried to dismantle the pump, starting with removing the bolts from the flanges, and they were so corroded that we couldn't get them loose by conventional means, so we elected to use an acetylene torch at that point. As soon as the flange separated, it exploded. I was burned over 90% of my body.
30 years and over 75 surgeries later, Mr. Capana now assists other burn survivors as they recover from their wounds, often suffered on the job.
Don't think that that something this tragic couldn't happen to you or somebody you love. This could happen to anybody.
John Capana's life was changed forever by a hot work accident. Welding, cutting, grinding, seemingly a routine operation, until suddenly flammable vapors are ignited by sparks or heat.
We typically hear about hot work accidents weekly. It's become one of the most significant types of incidents the CSB investigates in terms of deaths, in terms of frequency.
The Chemical Safety Board found that since 1990, welding, cutting, and other hot work on or near flammable storage tanks caused fires and explosions that led to over 60 deaths. In February 2010, the CSB issued a safety bulletin outlining 7 key lessons to prevent hot work accidents. The bulletin followed a tragic explosion that killed 3 paper mill workers in Wisconsin in July 2008, together with 10 other serious hot work accidents investigated or reviewed by the CSB.
The main message of the CSB Safety Bulletin is to conduct an effective hazard evaluation and perform gas monitoring before conducting hot work.
Proper use of combustible gas detectors would prevent many of these accidents and save lives.
June 5, 2006, a rural oil production site in central Mississippi, operated by a company called Partridge Raleigh. All the workers are contractors employed by Stringer's Oilfield Services, hired to install tanks and piping at the site. They plan to connect a pipe between 2 of the site's 4 tanks. They empty a large storage tank and then check it for flammable hydrocarbons by a dangerous and unreliable technique, inserting a lit welding torch into the tank. Seeing no flash, the workers believe it is safe to weld on the tank. However, crude oil has remained inside one of the other production tanks, warming under the morning sun. Vapor from this oil flows into an adjacent tank and escapes through an uncapped pipe just 4 feet from where workers plan to weld. Sparks shower down from the welding process, igniting the flammable vapor. Flames flash back into the storage tank, causing an explosion which blows off the tank lid and the ladder where 3 of the workers were standing. Flames shoot through a pipe into the next tank, causing an even more violent explosion. Three workers were killed, and the 4th was severely injured. CSB investigators noted that combustible gas detectors were not used at any time prior to or during hot work. Partridge Raleigh had not established safety requirements for its contractors, and the contractor provided no hot work safety training for its employees. Hot work accidents affect workers not only in the oil and gas industry, but also across other sectors, such as food production, paper, and wastewater treatment.
He was feeding you there. He was giving you a bottle.
In October.
And then you were looking at him like, what are you doing? Clyde and I were married about almost 2 years, together about 7. We share a child. Her name is Aaliyah Jones, and she is now gonna be 8, and she was 3 when he passed away. He was an all-around maintenance man at the Bethune Water Treatment Plant in the city of Daytona Beach. I just assumed that he had a normal, everyday, 7 to 3:30, Monday through Friday job. Safe as my job. And I would have never dreamed in a million years he would have been killed in an explosion.
January 11th, 2006. Clyde Jones is operating a crane at the wastewater treatment plant, while 2 other workers in a man-lift basket are removing a steel roof that covers 2 chemical storage tanks, one empty, the other containing about 3,000 gallons of highly flammable methanol. But no combustible gas testing is required or performed. The workers use an oxyacetylene torch to cut the roof into sections. Beneath them, methanol vapor vents from the top of the tank as the morning sun warms the liquid inside. Sparks from the torch shower down onto the tank, igniting the methanol vapor. The fire flashes into a corroded and ineffective flame arrestor and continues into the tank. Flames spread instantly, igniting the methanol inside. Burning methanol spews out from broken pipes, engulfing the 2 workers in the man-lift basket. One survives, one does not. Flames envelop the cab of the crane where Clyde Jones is sitting.
When Clyde got to Halifax Medical Center, him and I were able to talk for about 10 minutes before they intubated him. He told me that he loved me and to take care of the girls, and he knew he was bad. He just didn't know how bad. And he asked me if I would promise to stay with him until the end, and I told him I would.
The day after the explosion at the wastewater treatment plant, Clyde Jones, 40-year-old husband and father, died. The accidents at Bethune and Partridge Raleigh demonstrate the need to monitor the atmosphere for dangerous levels of flammable vapor. But monitoring must be done properly.
Ineffective monitoring techniques can be just as dangerous as no monitoring at all.
July 17, 2001, the Motiva Enterprises Refinery, Delaware City, Delaware. Several contractors are repairing a catwalk in a sulfuric acid tank farm. Their task involves cutting near storage tank 393, which contains waste sulfuric acid and flammable hydrocarbons. But the tank is severely corroded and has holes in its roof and shell. At about 7:45 a.m., Motiva operators use a combustible gas detector to test the atmosphere around tank 393. No flammable vapor is detected. They never test the atmosphere after that. But as the day goes on, the temperature rises by 14 degrees, warming the contents of the tank and producing vapor that escapes through the holes. But workers are unaware of the growing danger. Around 1:30 p.m., a spark from an electric arc cutting system ignites the vapor, causing a powerful explosion. The tank collapses, releasing 264,000 gallons of highly corrosive sulfuric acid. The sulfuric acid overwhelms the containment dike and wastewater systems. Almost 100,000 gallons reach the Delaware River, killing fish and other aquatic life. A contract employee who had been working on the catwalk died in the accident. His body never found. 8 others were injured.
Combustible gas detectors should be routinely used to identify and monitor for flammable atmospheres before and during hot work.
More recent accidents illustrate the same key lesson. Gas monitoring was performed at Conagra Foods in Boardman, Oregon on February 16, 2009, but not in the immediate area where welding was planned. Sparks ignited flammable gas from decaying matter beneath a water clarifier tank, causing an explosion that killed 1 worker. And 3 contract workers were killed at a TEPCO fuel terminal while they used a torch to cut into the roof of a gasoline storage tank. Gas testing occurred at 7 a.m., the start of the work shift, but was not repeated when workers returned from lunch or when they started the hot work.
Continuous monitoring for flammable vapor could have prevented these tragic accidents, which caused deaths, injuries, and environmental damage. Other good safety practices are also important.
Whenever possible, avoid hot work or consider alternative methods, such as cold or hydraulic cutting. Before any hot work, perform a comprehensive hazard assessment. Personnel may sometimes be unaware of processes that can release flammable vapors. In 2008, 3 workers were killed and 1 was injured in Tomahawk, Wisconsin at the Packaging Corporation of America, which manufactures corrugated packaging and containerboard. Welding sparks ignited flammable hydrogen gas from an 80-foot-tall storage tank. Unknown to plant employees, microbes were producing the gas from the decomposition of waste fiber inside the tank. Test the area where hot work is planned and eliminate potential sources of flammables even in equipment that is not directly involved. For instance, at Partridge Raleigh, emptying and purging the nearby crude oil tank would have eliminated the source of flammables. Use written permits specifically identifying the work to be conducted and the required precautions. At the Bethune wastewater plant, there was no permit system. Provide safety supervision for outside contractors conducting hot work. 2 contract workers were killed in LaRue, Ohio on October 19, 2008, when an explosion occurred while they were welding above crude oil storage tanks owned by Mar Oil. the company had no formal program to select or oversee contractors. And finally, train personnel on the hazards of hot work.
When there's any hot work involved, there needs to be additional training and safeguards put in place to make sure that the men or women that are doing the job are competent and well trained to do the job.
Use all your resources. Get as much training and as much information about the job at hand, and go into it with your eyes wide open.
Although the hazards of hot work are well known, frequent deaths and serious injuries continue to occur. The CSB believes that following the key lessons outlined here can help prevent future hot work-related accidents.
Welding and cutting. It's an intense scene. Sparks flying. Flames searing through metal. Extreme heat. There are a lot of different ways a mechanical construction or service worker can get hurt on a job site, and it should come as no big surprise that some of the most serious accidents occur when we're welding or cutting.
The mix of powerful electric current, highly flammable gases, and molten metal are a real recipe for trouble. That's why in our business we have to stay so focused on safety. So let's take a closer look at some of the more common hazards you face while welding or cutting, and how you can protect yourself.
We'll look at 3 areas: general hazards, personal protective equipment, and specific safety measures. So what are the general hazards we face? When you're electric arc welding, electrocution, or at a minimum, severe burns caused by electric shock are big concerns.
Electric current is measured in amps and milliamps. A milliamp is a tiny fraction of 1 amp, 1/1000th. It only takes around 70 to 100 milliamps to kill a person, and welding units typically operate with a current of 10 to 600 amps. I think you get the picture.
Another hazard of welding and cutting is eye damage, such as welder's flash, caused by ultraviolet radiation from the welding arc or cutting flame. We also have to be concerned about infrared radiation and visible glare, as well as sparks, slag, and other flying particles. Of course, you're typically dealing with metal that's heated to over 1,000 degrees, so you can get some nasty, painful burns caused by sparks, slag, or the hot workpiece itself. Welding and cutting may also release hazardous airborne substances like lead, zinc, and manganese. Under the right conditions, these can accumulate in your body and make you pretty sick. Last but not certainly least is the danger of fires and explosions.
Why do I include fires and explosions in the same category? Because an explosion is nothing more than rapidly accelerated burning.
Obviously, you don't want any part of these hazards. So, what do? You can start with your personal protective equipment. Wear leather steel-toe boots with high tops that fit tightly around your ankles, and long pants with no cuffs. That way, you minimize the risk of getting burned by a hot spark or a flying piece of slag getting trapped in your clothing. Many mechanical workers wear flame-resistant leggings or complete coveralls as extra protection from sparks and slag. Always wear long-sleeve shirts without pockets or cuffs for the same reason. And don't forget to check the fabric.
Synthetics like polyester melt and burn really easily, so make sure you don't wear anything to the job site that's made out of polyester or any other flammable material. Wear natural materials like cotton or wool.
And of course, heavy-duty welding gloves protect your hands from burns. Now let's take a look at your eye protection. You can use different shades of filter plates or lenses according to the type of welding or cutting you'll be doing. The key is to make sure you have on the right eye protection before you look at an arc or flame, even for an instant. The type of shade you use for electric arc welding depends on the size of the electrode and the amount of electrical current being generated. And if you're cutting with oxyacetylene, always use protective goggles with a number 5 shaded lens. Remember, if you're not sure what to wear, check with your supervisor before you start. You should also be sure to use safety glasses with side shields or safety goggles under your helmet to protect against sparks and slag.
It's especially hazardous when you're working in damp or wet areas. Tiny fragments of molten metal can shoot through the air if they come in contact with moisture. And another thing, a lot of us like having a hard hat on all the time, even when we're welding. In fact, hard hats are required 100% of the time on most job sites these days. With this rig, the face and eye shield built right into the hard hat makes it pretty easy to stay protected. Now you're wearing the right clothes, you have the right eye protection, and your hard hat is on. Your PPE is up to code. So, what else do you have to look out for? Plenty. Here's some measures you can take to protect yourself.
The biggest hazard in electric arc welding isn't from the heat, the sparks, the fumes, or the intense infrared radiation. The biggest hazard is electrocution.
Protect yourself by making sure that you are never a part of the electrical circuit, that you never become electricity's easiest path to ground.
Electricity flows from the power source through a wire to the tool or unit that uses the power, and returns through another wire to the power source. If you somehow become a part of that circuit by touching an energized wire or part of an energized electrode holder that's not insulated, you'll get shocked. How severe the shock is depends on how much current actually passes through your body on its way to ground.
So, always make sure that your welding unit is grounded and that the work itself is grounded. But also be sure to keep yourself insulated from the circuit. It just makes sense that the less chance you have of touching conductive materials, the safer you'll be.
So make sure the electrode holders and welding cables are well insulated. Check that the stinger leads are in good condition and avoid changing electrodes with your bare hands. Protect the insulation on your cables by arranging them so that sparks and slag won't land on them and melt parts of the insulation. That's how cables usually get damaged.
Also, water is a great conductor of electricity. That means you should always avoid electric arc welding in damp or wet environments without added insulation.
When you have to work in a damp or wet environment, make sure that you use welding mats as added protection against becoming the easiest path to ground.
Now let's talk about ways you can deal with respiratory hazards.
Metals that are heated up to the point where they can be cut or welded also give off fumes. Metal fumes like those from lead, zinc, or manganese can cause health problems in workers who inhale too much of them. The key is to make sure that your work area is always well ventilated. Talk to your supervisor about whether the ventilation in your work area is adequate for the type of work you're going to be doing and whether special respiratory protection is needed to keep you safe.
When you're working around hot metals, there's always the danger of sparks or hot slag landing in a pile of sawdust or rags. Pretty soon the sawdust is smoldering, and if the conditions are right, it can turn into a full-fledged fire. Keep your work area clean. Make sure your space is free and clear of any combustible materials like paper and trash, oily rags, and grease. Don't hesitate to grab a broom and clear yourself some room to work. And keep at least one Class ABC fire extinguisher nearby. Never know when it might come in handy.
Fires often smolder for a while until they burst into flame. Make sure there's nothing smoldering in your work area.
There are a number of things you can do to protect yourself against the chance of an explosion. First off, double check the ventilation in your work area.
If you can minimize any gas buildup near the heat and sparks of your cutting or welding work, you can also minimize the chance of an explosion. Inspect all cylinders, hoses, valves, and torches before using them. Make sure that any defective parts get repaired or replaced right away. And make sure your torch or regulator is equipped with a flashback arrestor. Flashback is an explosion caused by gases burning back inside the torch or hoses. A flashback arrestor will prevent these explosions. Always transport, use, and store gas cylinders safely secured in an upright position. And keep them well clear of ignition sources like sparks and flames. Also, store oxygen and other fuel gas cylinders like acetylene separately, at least 20 feet apart, or with at least a half-hour rated non-combustible barrier between them. Here are some other important safety measures to keep in mind. Don't store or use cylinders in heat above 125 degrees and never take them into confined spaces. Only use friction lighters to light a torch. Leave the wrench on the stem of the gas cylinder when you're using it so it can be turned off quickly in an emergency. As soon as you finish using the cylinders, turn off the gases, bleed the lines, remove the regulator, and replace the cylinder caps. Replacing the caps and keeping the cylinder secured in an upright position helps prevent against explosions, but it's pretty important for another reason too. If a cylinder were to fall over and break the valve or regulator, the pressure from the expelled gas could be enough to propel the cylinder across the work area like an unguided missile. Welding and cutting can be dangerous, but you can prevent problems if you stay focused on safety. Use your personal protective equipment. Ground the welding unit and the work, and keep yourself insulated from the path of the current. Also, use welding mats in damp or wet environments. Make sure your work area is well ventilated and always check to see whether respiratory protection is needed. Keep your work area clear of trash, sawdust, and other combustibles, and keep a Class ABC fire extinguisher close at hand. Store and use gas cylinders safely and properly. And use your head. Stay alert for potential dangers, and you'll be a healthy member of the mechanical construction trades for a long time to come.
The use of electricity is essential for carrying out our daily tasks, but it also poses significant risks if not handled correctly. Electrocutions are among the leading causes of workplace fatalities and injuries. In this video, we'll learn how to recognize electrical hazards in the workplace and discuss essential tips to avoid electrocution. Electrical hazards can be found in various areas of the workplace. Here are some of the most common electrical hazards. Frayed, damaged, or exposed wires can lead to electric shocks or fires. Always look for damaged cords and cables. Overloading circuits or plugging too many devices into a single outlet can cause circuits to overheat, which can cause fires or electrical shocks. Wet conditions. Water and electricity are a deadly combination. Working with electrical equipment in wet or damp environments increases the risk of shocks. Grounding on electrical equipment provides a safe path for electricity in case of a fault. Equipment without proper grounding increases your risk of getting electrocuted. Damaged or missing insulation can lead to serious electrical injuries. Insulation protects you from coming into contact with live wires. Regularly inspect electrical cords, tools, and equipment for signs of damage. Listen for unusual noises. Buzzing or crackling sounds near electrical equipment can indicate faulty wiring or connections. The smell of burning plastic or rubber can signal overheating or an electrical fault. If an electrical outlet, plug, or equipment feels unusually warm, it could be overloaded or malfunctioning. Now, let's go over some ways to avoid electrocution in the workplace. Always de-energize before servicing or repairing any electrical equipment or circuits. Lockout-tagout procedures should be followed to ensure the equipment cannot be energized while work is being performed. Be sure to turn off the power and verify it's off using a voltage tester. When working with electrical components, wear the appropriate personal protective equipment, such as insulated gloves, safety glasses, and flame-resistant clothing. Keep electrical equipment dry and away from water. If you must work in damp conditions, use ground fault circuit interrupters, GFCIs, to protect against shock. When working close to electrical equipment or power lines, use non-conductive ladder to prevent electrocution. Never use damaged tools. Modify them or use them in ways they were not intended. Avoid overloading circuits and distribute electrical loads appropriately. Never plug too many devices into a single outlet or power strip, and avoid using damaged or inappropriate extension cords. If you notice an electrical hazard, report it immediately to your supervisor or maintenance team. Do not attempt to fix electrical issues unless you are qualified and authorized. Pay attention to warning signs and labels on electrical equipment. These are in place to alert you to potential hazards and safe operating procedures. Next, let's review emergency response to electrical incidents. Knowing how to respond to electrical emergencies is just as important as preventing them. If someone is being shocked, do not touch them directly. Use a non-conductive object, like a wooden pole or a plastic item, to separate them from the electrical source. Immediately call emergency services and alert others nearby. Provide as much information as possible about the situation. If it's safe to do so, turn off the power source to stop the electrical flow. If trained and properly certified, provide first aid until emergency responders arrive. Electrical safety is everyone's responsibility. By recognizing electrical hazards and following these tips, you can significantly reduce the risk of electrocution and keep your workplace safe. Thank you for prioritizing electrical safety in your daily work.
Electrocutions are the second leading cause of worker death in construction, after falls. The primary cause of those electrocutions? Contact with underground and overhead power lines. Electricity can cook your body's tissues from the inside out in a matter of seconds, especially with the amount of energy that those power lines carry. If you are lucky enough to survive, the scars endured won't ever go away. But with careful planning and execution, such tragedies can be avoided. Hi, I'm Sergio with A&A Safety Environmental, and in this video we'll be going over the dangers of overhead power lines, along with some helpful tips that you can follow on your work site to work safely around them. Electrical power is brought to us through a three-part system. High-power transmission lines running from generating stations to substations, distribution lines, the same lines that run through most of our neighborhoods and job sites, and service drops running from poles to utility customers. Most of power line contacts and incidents reported to OSHA involve overhead distribution lines. That is most likely due to their location in respect to the construction work and the frequency in which they appear. The root cause of those reported incidents isn't always clear. Many investigations conclude that workers just didn't pay attention, or that they didn't take the hazard posed by overhead power lines seriously. However, there is one common trend in most power line cases. Workers, and all too often the supervisors, have an insufficient understanding of the hazards posed by overhead power lines. Many even operate under some false assumptions, such as believing that overhead power lines do not carry enough power to hurt a person, or that overhead power lines are mostly insulated. It is very dangerous to operate near overhead power lines under false assumptions, and without truly understanding their dangers. Hopefully this video can help you with that. Overhead power lines carry voltages ranging from 120 to 750,000 volts. For an electrocution to occur, a path to ground must be created for the current. So, if your body touches a power source, a power line in this case, the electricity will attempt to travel through your body seeking ground or another power source with a different electrical potential. And because of the resistance in our bodies, the path taken by the current heats up and burns the body tissues inside us. And once it's made its way through us, electricity leaves the body violently through that portion in contact with the ground, which is usually our legs and our feet, often leaving an exit wound. Well, that answers the question of whether power lines carry enough electricity to hurt you, doesn't it? Now that we understand why power lines are dangerous, let's talk about how and why power line contacts occur and what we can do to work safely around them. According to OSHA, the leading cause of accidental power line contacts involve heavy equipment such as cranes, excavators, and dump trucks, long-handed tools, ladders, and other items carried by workers while in close proximity to power lines. Just real quick, I want to ask you guys to do the favor, please subscribe into the fastest growing safety channel on YouTube. Don't look that up. Alright, let's get back to the video. The next time you work near overhead power lines, remember these crucial tips. Always keep a safe distance of 10 feet or more between you and your equipment from overhead power lines. Always survey the site for overhead power lines. In other words, look up. Always request an observer to assist you if it is difficult to maintain the desired clearance by visible means. Always require that the only job of the observer is to help the operator maintain that safe distance. Always treat overhead power lines as if they're energized. Always, when in doubt, call the electrical company to either de-energize and ground the lines or install insulation while you are working near them. Always use non-conductive tools and ladders near overhead power lines. Following these simple tips can significantly reduce the risk of being electrocuted by overhead power lines, so please keep them in mind the next time you work near one. We hope this video has given you a better understanding of the dangers of overhead power lines and how you can avoid making accidental contact with them. Stay tuned as there will be more to touch on this topic, including safe operation of heavy equipment near power lines, how to ensure power lines are de-energized and visibly grounded, and procedures to follow if you or a nearby coworker contacts a power line while operating heavy equipment. Would also love to hear from you guys in the comments. Is there a helpful tip regarding working near overhead power lines that I missed? Be sure to also follow us on all social media platforms to stay updated with our latest safety tips and tricks. And as always, until next time, be safe and thank you. Overhead power lines pose a significant electrocution hazard for anyone who works or operates high-reaching, heavy equipment near them. As employers, as employees, and as safety professionals, we can do everything in our power to minimize the risk of such a dangerous hazard. But unless we actually eliminate the hazard, that potential for an accident still exists. If a high-reaching heavy equipment such as a backhoe were to accidentally come in contact with an energized overhead power line, would you know what to do? Hi, I'm Sergio with A&A Safety, and in this video we'll be going over what happens when a piece of equipment contacts an overhead power line and the procedures to be followed if this happens on your site. In a previous video, we talked about how we can work safely around energized overhead power lines, especially when operating high-reaching heavy equipment. Whether you use an erected warning line with flags or a spotter, accidents can still occur, and it's important you understand what you should do and what you shouldn't do in those situations. Before we go into what we need to do if a piece of equipment does touch a power line, let's understand what happens when that contact is made and why it is so dangerous for the operator and everyone in the area. When a piece of heavy equipment contacts an overhead power line, the equipment then becomes energized and the current flows outward through the ground in a ripple pattern. Areas of high and low electrical potential fields circle the energized equipment like ripples in a pond after a stone hits the water. So if a worker steps in an area of high electrical potential to an area of low electrical potential, electricity can flow through their legs, causing injury or death. As a worker on the ground, if you see a piece of heavy equipment touch an overhead power line, stay as far away as possible from the machine, ropes, and load, since the ground around the machine may be energized. The operator and everyone around the equipment must be very careful to not touch any part of the equipment and the ground at the same time. If this contact is made, an electrocution, injury, or death can occur. As the operator, if you strike an overhead power line, remain in your cab and try to remove the equipment from contact by moving in the reverse direction from that which caused the contact. If the piece of equipment cannot be moved away from contact, the operator should remain inside the cab until the lines have been de-energized. Most equipment nowadays have insulated cabs, so the operator will be safe from electrocution inside that cab. Bailing out of the equipment should only be considered if there is a more immediate hazard present, such as the equipment catching fire. If bailing out must be performed, the operator must jump clear from the equipment and shuffle their feet in small steps, or hop with both feet leaving and landing on the ground simultaneously. Once everyone is a safe distance from the energized equipment, which should be at least 35 feet, secure the area and do not let anyone except emergency rescue personnel to go near the energized equipment. Always remember, the power flowing to the ground could easily injure and kill you. Then instead of one victim, there's 2 or 3. No matter what you think or feel, you can't go near an energized worker until you know for certain that that power is shut off. We hope this video has given you a better understanding of what happens when a piece of heavy equipment strikes an overhead power line and the procedures to follow in such a scenario. If you made it this far into the video, I just want to thank you and urge you to subscribe to the channel so you don't miss out on any future content that we drop. And while you're at it, hit that thumbs up to get this video out to more people and help them understand what they must do if this ever happens on their construction site. Would also love to hear from you guys in the comments. Have you ever been in a situation where a piece of heavy equipment hit a power line on your work site? How was that handled? Be sure to also follow us on all social media platforms to stay updated with our latest safety tips and tricks. And as always, until next time, be safe and thank you.
The objectives for today's session are to recognize situations that can lead to heat stress and other heat-related illnesses. You will learn the differences as well as the symptoms of heat stress, heat exhaustion, and heat stroke. You'll want to know how the body reacts, what steps should be taken to prevent heat stress and other heat-related illnesses. And finally, you'll learn what types of basic first aid can be helpful when dealing with fellow employees who experience heat-related illnesses. On average, 3,100 U.S. workers per year had a heat-related illness that caused them to miss work. Heat can build up in the worker's body and cause symptoms that range from headaches and dizziness to seizures, convulsions, and death. Factors leading to heat stress include high temperature and humidity, direct sun or heat, limited air movement, physical exertion, poor physical condition, some medicines, inadequate tolerance for hot workplaces, and insufficient water intake. Types of heat disorders include heat stroke, heat exhaustion, heat cramps, and heat rashes. Hot weather causes more fatalities than any other weather-related source. According to the National Weather Service's 10-year average, there were 170 heat fatalities between 1998 and 2007. During the same period, the average number of fatalities caused by hurricanes was 117. Recognizing the differences between heat stroke and heat exhaustion are crucial. Heat stroke is a medical condition that is life-threatening. The person's cooling system, which is controlled by the brain, stops working, and the internal body temperature rises to the point where brain damage or damage to other internal organs may result. Internal temperature may reach 105 degrees Fahrenheit or higher. Heat exhaustion often occurs when people work in a hot, humid place and body fluids are lost through sweating, causing the body to overheat. Temperature may be elevated but not above 104 degrees Fahrenheit. The illustration depicts a heat stroke victim with dry, hot skin on the left and heat exhaustion with moist, clammy skin on the right. Heat exhaustion comes from dehydration. The skin may be cool and moist. The victim's pulse rate will be fast and weak, and breathing will be fast and shallow. If heat exhaustion is untreated, it may progress to heat stroke, which is a medical emergency. Warning signs of heat exhaustion include heavy sweating, paleness, muscle cramps, tiredness, weakness, dizziness, headache, nausea or vomiting, fainting. Symptoms of heat stroke can sometimes mimic those of heart attack or other conditions. Sometimes a person experiences symptoms of heat exhaustion before progressing to heat stroke. Symptoms of heat stroke include fever, irritability, dry, hot, red skin, confusion, bizarre behavior, no longer sweating, fainting, rapid but shallow breathing, rapid but weak pulse, seizures. Over 20% of those who suffer a heat stroke die. The key difference between heat exhaustion and heat stroke is the presence of mental status changes. When heat illness symptoms are presented, you'll need to respond quickly. First, move the person out of the sun or hot environment and into a shadier air-conditioned space. If fever greater than 102 degrees Fahrenheit, fainting, confusion, or seizures occur, dial 911 or call for emergency medical assistance. Cool the person by covering him or her with damp sheets or by spraying with cool water. Direct air onto the person with a fan or newspaper. Finally, have them drink cool water. If they're able, a half a cup of water every 15 minutes is a good start. If symptoms do not improve, seek medical help immediately. It is easier to prevent heat illness than to treat it once symptoms develop. If possible, acclimatize for up to a week when working in hot weather conditions. This allows your body to gradually adapt to the heat. Hydrate well before thirst kicks in. Once you are thirsty, you are already dehydrated. Drink every 15 minutes or 6 to 20 ounces an hour. Wear light, loose clothing such as cotton so sweat can evaporate. Better yet, invest in wicking or cooling garments like Cool Zone Tech or Miracool bandanas. Use sunscreen to prevent sunburn, which can hinder the skin's ability to cool itself. Wear a hat that provides shade and allows ventilation. If you feel your ability start to diminish, stop activity and try to cool off. Do not drink alcohol or beverages with caffeine because they increase the rate of dehydration.
Safety rules and regulations that we know under the Hazard Communication Standard are now changing, including changes in the material safety data sheets, labels, and warning requirements. OSHA's Hazard Communication Standard, known as HAZCOM, will now integrate into the United Nations globally harmonized system of classification and labeling of chemicals. It will now be known as the Hazard Communication and Globally Harmonized System, or simply the GHS. The purpose of this video is to review the major changes that you're going to see. the GHS, or Globally Harmonized System, will now require chemical manufacturers to provide specific criteria to address health and physical hazards, as well as classification of chemical mixtures. Labels will be required to show much more information than before. For example, chemical manufacturers and importers must provide a label that includes a signal word, a pictogram, a hazard statement, and precautionary statement for each hazard class and category. What we now know as material safety data sheets are now going to be shortened in name and will be known simply as safety data sheets, or SDS, instead of MSDS. The safety data sheets, or SDS, will now have a new format that has 16 specific sections, ensuring consistency in presentation of important detection information. OSHA's Hazard Communication Standard is designed to ensure that information about chemical hazards and associated protective measures are disseminated to all workers. This standard has been revised to include the GHS. The major changes you should know right now are hazard classification. This replaces hazard determination. Hazard classification provides specific criteria for classification of health and physical hazards, as well as classification of mixtures. Labels. Chemical manufacturers and importers will be required to provide a label that includes a harmonized signal word, pictogram, and hazard statement for each hazard class and category. Safety data sheets will now have a specified 16-section format. In the new GHS, all chemicals will now be classified into 3 major hazard groupings. The first and the largest is physical hazards. This includes items like explosives, flammable gases and aerosols, flammable solids, gases under pressure, self-reactive substances that can react violently with water, and other solid substances that emit a flammable gas when wet, oxidizers like oxygen and hydrogen peroxide, and corrosives, which are either strong acids, strong bases, or concentrated solutions of certain weak acids or weak bases. They can exist as any state of matter, including liquids, solids, gases, mists, or vapors. The next major hazard group is health hazards. Examples of health hazards include acute toxicity. For example, hydrogen cyanide is a highly toxic substance. Acute exposure at relatively low doses can result in death. Skin corrosions or irritants can cause severe skin burns and/or eye damage. Another health hazard is serious eye damage or eye irritation, then respiratory or skin sensitization. Sensitizers can cause severe organ damage or major permanent functional changes in organ systems, for example, the lungs. Germ cell mutagenicity. These are chemicals which may cause mutations in the germ cells of humans, and then these mutations can be transmitted to offspring. Carcinogens. These are chemicals associated with causing cancers. Other toxic chemicals that affect the reproductive organs or other specific organs, and aspiration hazards. The third major hazard grouping is environmental hazards. This is new, and OSHA does not have jurisdiction over environmentally toxic chemicals. The labeling and SDS requirements under GHS require environmental labeling, but OSHA considers this portion of the standard non-mandatory, as environmental hazards are regulated by the EPA. Therefore, we will not be concerned with this area. It is being mentioned here for information purposes only. Let's talk about the Material Safety Data Sheet, or as we know it now, the old MSDS. The old MSDS has been found to be less useful in many circumstances because it did not contain enough information. The new Safety Data Sheets, or SDS, will replace the 9-part MSDS with a 16-part document. Although that sounds more complicated, you will find that much more information is being presented in a much better way. The SDS is product related, and although it is not able to provide information that is specific for any given workplace where the product may be used, the expanded SDS information will include much more data funneled down into a better document to help us understand the chemicals we are using. The SDS will enable people to develop an active program of worker protection measures, including training that is specific to your individual workplace, and to consider any measures that may be necessary to protect the environment. Information in an SDS also provides a source of information for other workers, such as those involved with the transport of dangerous goods, emergency responders, poison centers, and finally, consumers. The new standardized SDS format will make finding hazard and chemical information on the SDS easier for both employers and employees. There is no set format to the material safety data sheet, and they can range in length from 1 page to 20 or more pages. The new safety data sheet will contain only 16 headings. All SDS will be in this standard format, which will make it easier for all of us to find the information that we need for our workplace. The SDS headings, sequence, and content are similar to many of the items required by other regulatory organizations. Reviewing the headings gives you an idea of how comprehensive the information will be. In the new standardized format safety data sheets, the first thing that will be provided is an identification of the product or chemical. Next, the hazards within the product will be identified, and then the composition or other information will be provided about ingredients. First aid measures will be discussed, as well as fire fighting measures, and that will be followed by a section that discusses how to handle accidental releases. Handling and storage is the next category, and then the 8th category will discuss exposure control or your personal protection, what kind of PPE may be needed handling the product. Physical and chemical properties will be explained, followed by the stability and reactivity information, and then toxicological information. The next 3 sections, ecological information, disposal considerations, and transport information, are not required by OSHA, but may be included in the safety data sheet. And the last 2 sections will be regulatory information, and then any other information deemed pertinent by the manufacturer or an outside regulatory agency. Here are the first 2 pages of a sample safety data sheet. Note the specific sections. All safety data sheets will have the sections or headings in this order and in this format. This will make finding specific information much easier. There is not a standard format for the GHS label. However, there are required label elements. The GHS label elements that you see here with an asterisk have been standardized and are directly related to the hazard level. The other label elements are defined based on common definitions. But these 3 elements, hazard pictograms, signal words, and hazard statements, are all hazard warnings and are required to be grouped together on the label. The symbols, signal words, and hazard statements have all been assigned to specific hazard categories and classes. On labels the GHS system uses, only 2 words, danger and warning, are used to inform the chemical user of the severity of the hazards of the chemical. The use of just 2 signal words is used to help simplify warnings and the labeling system. For example, thinking about the word danger, imagine yourself driving up to an intersection with a stop sign. This signals to the driver that this is a potentially dangerous intersection and that the driver is required to stop and look before proceeding through the intersection. If the signal word on a label is danger, the chemical user should understand that this is a highly hazardous chemical and they should stop and become familiar with all the characteristics of the product before proceeding. On the other hand, if the label contains the word warning, this is like driving up to an intersection controlled by a yield sign. The driver can proceed through the intersection with caution, as it also has the potential to be a hazardous intersection. However, labels that contain the signal word warning indicates that the severity of hazards of the chemicals are less than those chemicals classified with the signal word danger. Hazard statements are supposed to give the chemical user additional information about the hazard that is depicted in the pictogram. For example, if you saw the flame pictogram on a label for a flammable liquid, the hazard statement might be, keep away from fire, sparks, and heated surfaces. As stated earlier, hazard statements have been standardized and the chemical manufacturer, importer, or distributor is responsible for using the appropriate hazard statement or statements on the label. The other statements shown are more examples of standardized hazard statements. Pictograms are now required. Only 8 are required by OSHA, but a 9th may also be used to indicate environmental hazards. The labels for hazardous chemicals must contain 1 or more of the pictograms to illustrate the hazards of the chemical. The exclamation mark pictogram, when shown by itself on a label, is for chemicals that have toxicity levels that are harmful to humans but are not usually fatal. This includes chemicals that can be irritants to skin and eyes. For example, pepper spray is a skin and eye irritant, and many soaps, detergents, and cleaning products like ammonia and chlorine can be irritants. The exclamation mark pictogram will also be used to show skin sensitizers, acute toxicity, narcotic effects, respiratory tract irritants, also something that could be hazardous to the ozone layer. However, this would not be mandatory under OSHA. While the chemical hazards associated with the exclamation mark pictogram are a concern and precautions need to be taken, they are not as dangerous as the health effects or hazards associated with the health hazard pictogram. Health hazard means a chemical that can cause acute or chronic health effects in exposed personnel. Chemicals like gasoline, benzene, acetone, and products like brake cleaner or anything containing volatile organic compounds will have the health hazard pictogram on the label. When you see the health hazard pictogram, the product or chemical will fall under the list of potential health hazards, including the group mentioned earlier. The flame pictogram indicates the product or chemical has flammable or self-reactive characteristics or other hazards as listed here. This is the pictogram for all gases under pressure. Don't be fooled by the picture of the cylinder because it covers much more. This symbol includes all cylinders, propane tanks, natural gas tanks, refrigerated liquids, and many other products in this category. The chemical hazards associated with the corrosion pictogram are skin corrosives and can cause permanent eye and skin damage. This symbol, one that is seen commonly in the military, is one we don't see very often in private industry unless of course you handle ammunition, explosives, and so on. Oxidizers are symbolized by an O with flames on top of the O. The skull and crossbones pictogram is for chemicals with acute toxicity effects that are deadly and could lead to fatality if not handled correctly. The dead fish and trees symbol signals environmental information. This is non-mandatory under the OSHA standard as OSHA does not regulate environmental hazards. As we said before, the EPA regulates environmental hazards and the chemical manufacturer, importer, or distributor would be required to comply with EPA regulations in addition to the OSHA labeling requirements. Here is an example of the labels you may see under the new GHS rules. As stated earlier in this presentation, there is no standard format required for the GHS label, so the information may or may not be in the order presented here. In fact, you can anticipate that most labels will look different from each other. The thing you need to keep in mind is that even though labels will look different, the information they will be required to list on the label is the same, and you should understand how to read and use the data presented. Other items required to be on GHS labels include precautionary statements. These are phrases that describe recommended measures that should be taken to minimize or prevent adverse effects resulting from exposure to a hazardous chemical or improper storage or handling. The precautionary statements would be the same on the label and on the safety data sheet for the product. The product identifier. This is how the hazardous chemical is identified. This can be, but is not limited to, the chemical name, code number, or batch number. The manufacturer, importer, or distributor can decide the appropriate product identifier. The same product identifier must be both on the label and in Section 1 of the safety data sheet. The supplier identification. The name, address, and telephone number must be provided on the label. You may also see statements pertaining to any pertinent supplemental information. This could be information added at the discretion of the manufacturer or distributor, or it might be information required by another regulatory agency. If a chemical manufacturer, importer, or distributor becomes aware of a new hazard for a chemical they produce, they have 3 months to update the label and the safety data sheet for that product or chemical. For example, if new research finds that a product was recently found to be carcinogenic, the chemical manufacturer, importer, and or distributor will have 3 months from the time they are aware of the carcinogen health hazard to change the label and safety data sheet for the chemical to include the new health hazard carcinogen information. This presentation summarizes major modifications of the Hazard Communication Standard to the globally harmonized system. We are exposed to chemicals and chemical products every day. You can find them in your workplace, your home, in schools, hospitals, hotels, just about everywhere. Exposure to hazardous chemicals is one of the major hazards in the workplace. Knowing how to find and understand information on the chemicals around you will help protect you, your co-workers, and your families. Thanks for watching, and have a safe day.
Despite being bigger and far more complex, today's workplaces are the most environmental and safety-conscious workplaces in all of history. With corporate commitment from the top down, risks and hazards are readily identified, often eliminated, or at the very least, managed with a high degree of control. This will only be maintained through a continuous process of monitoring and evaluation, awareness and empowerment, and most of all, a heightened sense by all in the workplace of the potential for accidents and incidents to occur in any circumstance, under any conditions, and at any time. With this in mind, we ask that you pay particular attention to the following video. Sometimes referred to as sewer gas, sour gas, or swamp gas, hydrogen sulfide gas, or H2S as it is more readily known, is an extremely hazardous and toxic compound. It usually presents to us in the form of a gas. H2S is colourless and in large concentrations odourless. To make matters worse, it is also extremely flammable with a low ignition point of only 260 degrees. To put that into some perspective, the tip of a cigarette burns at approximately 700 degrees. H2S has a high flammability range, with ignition possible anywhere from 4.3 to 46% gas-to-air ratio. In other words, H2S is easily ignited in almost any conditions. H2S occurs naturally as a result of decaying organic matter, particularly in low oxygen environments. You are therefore likely to encounter H2S in sewers, mines, hot springs, and of more relevance to your workplace, in conjunction with entry into geological formations during the process of oil and gas extraction, both on and offshore. With a vapour density of 1.19, hydrogen sulfide is approximately 20% heavier than air. So this invisible and potentially odourless killer will gravitate and pool at the lowest possible points, like pits, holds, tanks and depressions, etc. H2S is soluble. It will remain confined within water, oil, sludge or mud until it is agitated, depressurized or heated, at which point it will then rapidly expand and mix with the available air. Consequently, it is usually encountered in work areas like the shakers or the drill floor. Other primary zones for H2S detection include the BOP, moon pool, pump room and pit room. However, if gas is known to be present, all areas should be viewed as potential collection points. For measuring purposes, we use parts per million, ppm. So when a description or measure of gas is made, it refers to how many parts or units of gas are present in a million units of air. 10 ppm therefore means that there are 10 units of gas present in every 1 million units of air. Hydrogen sulfide has a very low odour detection threshold. Even at low concentrations, well below 1 part per million, its rotten egg smell is often perceptible. The odour does increase as the gas becomes more concentrated, up to about 30 parts per million. Above this level, and up to around 100 parts per million, the gas is purported to have a sickly sweet odour. At concentrations above 100 parts per million, your ability to detect H2S is affected by a rapid paralysis of the olfactory nerves in the nose, leading to a loss of the sense of smell. In effect, at this level the gas is undetectable to the human nose. This means that when H2S is present in dangerously high concentrations, it has no perceivable odour. Prolonged exposure to lower concentrations can also result in a loss of the sense of smell. This unusual property of hydrogen sulfide makes it impossible and extremely dangerous to rely on your sense of smell to warn of the presence of the gas. The primary route of entry into the body is through inhalation, through the nose and mouth. If H2S is inhaled in low quantities, the body can break it down, However, over time, or in high concentrations, the body will not break it down fast enough, leading to paralysis of the respiratory system. H2S is classed as a chemical asphyxiant, similar to cyanide. It kills by inhibiting cellular respiration and therefore the uptake of oxygen, resulting in biochemical suffocation. Let's take a look now at the typical exposure symptoms. At low concentrations, 0 to 10 parts per million, you will feel an irritation of the eyes, nose and throat. You will also experience its potent rotten egg smell. At moderate concentrations, that's 10 to 50 parts per million, you may experience headache, dizziness, nausea and vomiting, coughing and difficulty in breathing, and you now may no longer be able to smell the gas. At high concentrations, 50 to 200 parts per million, you will experience severe respiratory tract irritation, eye irritation, shock, convulsions, coma, and eventually death. In extreme concentrations, 300 parts per million and over, death is rapid. Prolonged exposure, even at lower levels, can lead to bronchitis, pneumonia, migraine headaches, pulmonary edema, and the loss of motor coordination. In short, H2S is a gas that is invisible, undetectable to the human nose, extremely deadly, and highly flammable in almost any concentration. H2S is also highly corrosive to certain metals and may cause a buildup of iron sulfide within steel pipe. Should moisture be removed from this compound, it may spontaneously combust, burning on its own. The corrosive nature of the gas may result in the progressive weakening of pipes and fittings, thereby increasing the likelihood of leaks, leading to an increased potential for exposure incidents. Sound maintenance and planning is required to manage this risk. H2S is often disposed of by burning or flaring off. When burned, it produces another deadly gas known as sulfur dioxide, or SO2. Most countries have legal limits in force that govern the maximum allowable levels of exposure to H2S in the workplace. A typical permissible exposure limit in many countries is 10 parts per million. However, your workplace safety officer will inform you of the permissible working exposure levels as they pertain to your particular circumstances. While the distinctive odour of H2S is easily detected at low levels, its ultimate sensory fatigue effects means that your nose cannot be relied on as a warning device. The only reliable way to determine exposure levels is to measure the amount of H2S in the air through the use of monitoring systems. The various systems include personal monitors, portable monitors, and fixed-point monitoring systems. Regular monitoring will help to identify areas and operations likely to exceed permissible exposure limits. Any areas that routinely pose overexposure hazards must be equipped with continuous monitoring systems. The use of direct reading gas detection instrumentation is therefore required before entering confined spaces, such as manholes, tanks and pits, etc. Where engineering controls cannot adequately manage the level of exposure, it may be necessary to supplement them with the use of suitable personal protective equipment, such as supplied air respirators. A qualified industrial hygienist or a H2S safety professional should be consulted for guidance on the suitability and correct use of respirators. Your workplace will be equipped with one or more of the following: self-contained breathing apparatus, supplied air breathing apparatus, emergency life-saving apparatus. Wherever possible, exposure should be minimised by employing adequate engineering controls, including hot work permits and safe working practices, inclusive of buddy systems. Should a co-worker ever be overcome by H2S gas, do not attempt a rescue until you are properly protected yourself. The rescuer can very easily get caught out by venturing into a gas-affected zone without adequate protection. Remember, at levels above 200 parts per million, collapse, coma and death due to respiratory failure can occur within seconds and after only a few inhalations. so you can be very quickly overcome yourself. Such incidents are sadly all too common and only serve to make a successful rescue all the more difficult. Your workplace will be fitted with gas alarms and have detailed emergency response procedures contained within your workplace procedures manuals. Your H2S briefing officer will advise you on your workplace-specific procedures following this presentation. You should take the time to ensure you fully understand the current H2S risks in your workplace and the correct procedures and responses in relation to H2S exposure, alarms, and emergency procedures. Thank you for your time, and remember, don't mess with H2S.
No matter how close we look, we can't see the hour and minute hands on the clock move. We know they do, however, and when we look later, we're not surprised to find they've traveled around the dial. In the sky, the sun seems to stand still. But we know the Earth is constantly rotating, and in a few hours, the sun will slip below the horizon. When changes happen slowly, we may not perceive them at that moment, but that doesn't mean they're not occurring. Silica can accumulate so slowly in the lungs that an unprotected worker may not realize what's happening. It's only later, after significant damage is done, that it becomes obvious. Fortunately, by taking the proper precautions, you can avoid ever experiencing the debilitating illnesses caused by breathing in silica dust. In this program, we'll discuss silica's risks, a healthy work environment, and best work practices. Silica is the second most common mineral found in the Earth's crust. One form of silica, called crystalline silica, can be a serious health hazard. Crystalline silica is found in lots of places in nature and industry, including mineral deposits, rock and stone, granite, sandstone, slate, cement mortar, concrete, brick, and blasting abrasives. If crystalline silica is so common and also dangerous, why aren't we all sick from it? Because it only becomes dangerous when it's turned into dust and breathed in. In certain industries, this poses a real risk. According to the Center for Disease Control, at least 1.7 million U.S. workers are exposed to respirable crystalline silica in occupations such as construction, sandblasting, and mining. If precautions aren't taken to protect these workers, they can face a number of life-threatening illnesses, including cancer, tuberculosis, and autoimmune diseases. But the illness most closely tied to silica is silicosis. Silicosis is a lung disease that kills more than 250 workers in the United States each year and disables many more. It's caused when breathed-in crystalline silica dust settles in the lungs. Over time, as the silica accumulates, the lungs become inflamed and scar tissue forms. At first, an affected worker doesn't experience symptoms, but as the scarring gets worse, the lungs stiffen and have an increasingly difficult time extracting oxygen from the air that's breathed in. Then symptoms do begin showing up, including shortness of breath, tiring easily, and chronic coughing. If exposures to crystalline silica continue, the health problems inevitably grow more severe. How long does it take for symptoms to develop? That depends on how concentrated a worker's exposure to silica is. Silicosis is divided into three categories: chronic, accelerated, and acute silicosis. The most common form of the illness is chronic silicosis. Typically, chronic silicosis takes 10 to 20 years to develop and occurs when a worker is exposed to low amounts of silica over a long time period. Because a chest X-ray may not reveal any signs of the illness in its early stages, a worker can have chronic silicosis for years before it's diagnosed. The second category, accelerated silicosis, sometimes called progressive massive fibrosis, occurs when a worker is exposed to higher levels of silica. Because the worker is breathing in more silica, symptoms take only 5 to 10 years to develop. The rarest form of the illness, acute silicosis, occurs when a worker experiences a short-term exposure of extremely high levels of silica. Symptoms of acute silicosis can develop very rapidly, within only a few weeks, or may take up to 5 years to appear. At its worst, death from acute silicosis can occur within a few months, with the lungs literally drowning in their own fluids. Unfortunately, if a worker does develop silicosis, there is no cure. Once the lungs are scarred, the damage is irreversible. Because there is no effective treatment for silicosis, knowing how to protect yourself when working around silica dust is critical. And that's the good news. Silicosis and other illnesses associated with crystalline silica are 100% preventable. According to OSHA, there is potential for danger only when crystalline silica particles are in the air. There may be materials that contain silica, but if the operations on those materials do not generate dust, there is little chance of inhaling silica. So the danger occurs when materials that contain crystalline silica are drilled, sawed, crushed, or worked on in some other way that creates dust. But when determining if you're at risk, it's also important to remember that there may be silica particles in the air even though you don't see them. In other words, your senses alone won't tell you if you're being exposed to hazardous levels of silica. For an accurate assessment of airborne silica levels, employers rely on air monitoring. By collecting air samples and analyzing them, it can be determined if workers are exposed to crystalline silica levels above OSHA's PEL or permissible exposure limit. This is the maximum amount of crystalline silica that is considered safe during an 8-hour shift. If exposure levels are over the PEL, then action must be taken to bring them down. Whenever possible, the best way to reduce or eliminate employee exposures is through engineering and work practice controls. An example of an engineering control is to enclose work processes so that dust can't escape. Other controls may include switching to materials that don't contain crystalline silica, using local exhaust ventilation systems, and employing wet drilling or sawing to reduce the amount of dust that gets kicked into the air. In some situations, however, controls either won't work or can't bring dust levels down far enough. When this is the case, personal protective equipment is required. Since we're talking about protecting the lungs, choosing an appropriate respirator and using it properly are absolutely critical for adequate protection. If you need a respirator for your job, your employer will help select one based on the amount of silica dust in the atmosphere, as well as the type of work being performed. They'll also provide a fit testing procedure. A fit test makes sure that the respirator fits the contours of your face snugly so that dust can't enter along the sides of the mask. After that, it's up to you to don the mask properly when it's needed. While safety measures like these help protect your health, the National Institute for Occupational Safety and Health, or NIOSH, also recommends that employees who work around silica receive regular medical exams. Because the number one health concern from silica exposure, silicosis, is difficult to detect in its early stages, medical monitoring helps ensure that health problems aren't developing that you're unaware of. A full exam should include a chest X-ray and lung function test. NIOSH recommends that the first exam takes place before starting the job. After this, exam should be given at least once every 3 years. Air monitoring, engineering controls, respirator selection. Up to now, we focused primarily on ways that your employer provides a safer work environment. Now, let's look at day-to-day activities, those best work practices that employees use to keep themselves safe while on the job. Of course, the first step in protecting yourself is knowing whether the materials you're working with pose a risk. To help you determine this, any material that contains more than 0.1% crystalline silica must meet the information requirements of the Hazard Communication Standard. In other words, these materials must be properly labeled and a Material Safety Data Sheet, or MSDS, must be available at your job location. Before working with any new materials, read over all labels and MSDSs so that you know what risks are present and how to proceed safely. Awareness is key to staying safe. Know in which areas of your facility crystalline silica exposure is a possibility and the specific operations that create hazardous dust. Then take the appropriate precautions. At the start of your shift, changing into disposable or washable clothes will make it easier to leave the dust safely behind at the end of the day. Always wear the correct PPE for the task you're performing. Depending on the activity you're involved in, this may include a hard hat, gloves, hearing protection, eye and face protection, and shoes with reinforced toes or other protective qualities. Of course, where silica is present, this may also include a respirator. Always wear the appropriate respirator for your work environment and exposure level. Don't make the mistake of thinking a cloth such as a bandana or t-shirt pulled over your nose and mouth will protect you. These provide little or no respiratory protection. Before donning your respirator, inspect it. Check for tears, cracks, broken straps, or any other damage that may impair the respirator's ability to protect you. Each time you don the respirator, perform a seal check. Different masks may require slightly different procedures, but typically, during a seal check, you'll block the respirator's air inlets with your hand and either inhale or exhale into the mask. If air escapes around the sides of the mask, readjust the respirator's position on your face until a good seal is achieved. Be aware that beards and mustaches can interfere with a respirator's seal, reducing the respirator's effectiveness. Never go into a hazardous atmosphere with a respirator that is damaged or that doesn't provide an airtight seal. Either will expose you to the hazard you're trying to avoid. At the end of your shift, always clean and store your mask properly to ensure that it will continue to protect you in the future. If you have questions about specific respirators used at your facility, ask your supervisor or safety professional. When working with silica, remember this rule of thumb. If you don't see any dust, you may still be at risk. But if you can see dust, you're almost definitely at risk. Whenever possible, avoid standing in a visible cloud of dust. If your job takes you outside, park your vehicle where it won't become contaminated with silica, and while working, try to position yourself upwind from any sources of silica dust. Maintaining a safer work environment means minimizing silica dust wherever possible and reducing the amount of dust that gets into the air. Engineering controls are intended to help with this, so make sure those controls are well maintained and tell your employer if control systems do not seem to be working properly. Good housekeeping practices and personal hygiene are also critical to eliminating silica exposure. As much as possible, keep exposed surfaces in your work area free of silica dust, but use cleaning methods that won't throw dust into the air. For example, clean up using wet sweeping, a water hose, or a vacuum with a high-efficiency particulate filter, as opposed to techniques such as dry sweeping or compressed air that scatter the fine dust. Do not eat, drink, smoke, or apply cosmetics in areas where crystalline silica dust is present. Instead, first move out of the exposure area and thoroughly wash your face and hands before engaging in any of these activities. To further protect your health, consider giving up smoking altogether, since smoking adds to the damage caused by inhaling silica dust. At the end of your workday, if possible, shower at the worksite and change into clean clothing to prevent contaminating other work areas, your vehicle, or your home. While silica is a serious health hazard in many work environments, the prevention methods outlined in this program work. Since OSHA first implemented regulations to control silica exposure, instances of silicosis have declined. Next time you step onto a job site where silica is present, reduce your risk of silica-related health problems by remembering to participate in educational and health programs provided by your employer. Read all relevant label and MSDS information for the materials you'll be working with. Know areas and operations where crystalline silica exposure is a possibility. Make sure all engineering controls are functioning properly. Use appropriate PPE when needed. Avoid dust clouds and working downwind from silica operations. If a respirator is required, follow the manufacturer's instructions for the proper donning and use. Reduce exposure risks through good housekeeping and personal hygiene practices. And finally, if you have any questions about silica exposure or other health-related issues, ask your supervisor or safety professional. The illnesses caused by breathing in silica may take time to develop, but they're too serious to ignore. To help ensure that your lungs stay healthy into the future, choose every day to work safely around silica.
Before we discuss chemicals and hazardous materials, it's important to understand some basic terms. You may or may not be familiar with these terms, but if you handle, use, store, or dispose of chemicals and hazardous materials, it's very important to understand the terminology. ppm is a term that is quite familiar to anyone working with chemicals and toxic materials. It means parts per million. The health effects of any toxic substance are related to the amount of exposure, also known as the dose. The greater the dose, the more severe the effects. Some chemicals can cause toxicity at very low doses, so it is important to be able to understand how these very small amounts are described. It is especially important to understand how low doses compare to one another and what they represent when compared to amounts of more familiar substances. Parts per million, ppm, parts per billion, ppb, and parts per trillion, ppt, are the most commonly used terms to describe very small amounts of contaminants in our environment. They are measures of concentration, the amount of one material in a larger amount of another material. An example might help illustrate the part per million, part per billion, and part per trillion equations. Let's use 1 part per billion. To give you an idea of how little this would be, a pinch of salt in 10 tons of potato chips is also 1 part salt per billion parts chips. Similarly, 1 part per billion of an impurity in water represents a tiny fraction of the total amount of water. 1 part per billion is the equivalent of 1 drop of impurity in 500 barrels of water. Permissible exposure limit, or PEL. This is an exposure limit that is published and enforced by OSHA as a legal standard. PEL may be either a time-weighted average TWA exposure limit within an 8-hour period of time, or a 15-minute short-term exposure limit STEL, or a ceiling C. Threshold limit value, TLV. Threshold limit value is an airborne concentration of substances that represent conditions under which it is believed that nearly all workers may be exposed day after day with no adverse effect. TLVs are advisory exposure guidelines, not legal standards. TLVs are based on evidence from industrial experience, animal studies, or human studies when they exist. There are 3 different types of TLVs: time-weighted average, TLV-TWA, short-term exposure limit, TLV-STEL, and ceiling, TLV-C. Time-weighted average, TWA. The average time over a given work period, such as an 8-hour workday, of a person's exposure to a chemical or an agent. The average is determined by sampling for the contaminant throughout the time period, represented as TLV-TWA. IDLH, immediately dangerous to life and health, which represents the maximum concentration of a chemical in the air to which a healthy adult worker could be exposed for 30 minutes without suffering permanent or escape-impairing health effects. Okay, we know about PEL, or permissible exposure limit, threshold limit value, time-weighted average, STEL, or short-term exposure limit, and TLVC, or ceiling, and IDLH. These terms are used to determine your exposure to concentrations of chemicals and what protection you need to reduce exposure to potentially harmful chemicals. Chemicals are often flammable, combustible, toxic, corrosive, and other hazards, so you have to know and learn this information as part of your job responsibilities. Let's examine the chemical benzene. In this program, we'll discuss some of the hazards of the chemical, how it's identified, and how to determine if you're being exposed. Basic workplace exposure limits, ways of reducing your exposure, medical information, and general safe work practices. We will also review information relating to protection from benzene exposure, such as personal protective equipment and respiratory protection. To get started, let's take a look at some of the hazards of this chemical. Benzene can affect you when breathed in and by passing through your skin. Benzene is a carcinogen, which means it can cause cancer, so handle with extreme caution. It can irritate the eyes and skin with drying and scaling of the skin. Benzene can irritate the nose and throat and can cause symptoms of dizziness, lightheadedness, headache, and vomiting. High exposure may result in convulsions and coma or sudden death from irregular heartbeat. This tells you that benzene is a dangerous chemical if not handled properly. Prolonged exposure can cause damage to the blood. It is a flammable liquid and a fire hazard. You will receive additional training to help determine exposures, but your company provides routine evaluations, including collection of air samples. If you believe you are experiencing any work-related health problems, notify your supervisor, so a doctor specifically trained in recognizing occupational diseases can make that determination. The information provided here is basic, and your company may have more stringent requirements for exposure limits. The legal airborne PEL, or permissible exposure limit, is 1 part per million, averaged over an 8-hour period work shift. 5 parts per million should not be exceeded in any 15-minute period of time. The range of accepted odor threshold values is 34 to 119 parts per million. In other words, it takes about 34 to 119 ppm for you to detect this chemical, which is 33 to 118 times the permissible exposure limit. Caution should be used in relying on odor alone as a warning of potentially hazardous exposure. Some chemicals have characteristics that can be perceived by workers and can serve as a warning of the chemical's presence. The lowest concentration at which the odor of a chemical can be detected is called the odor threshold. Some substances, such as asbestos, have no odor and therefore provide no warning of their presence. In many cases, the concentration of a chemical that can be detected by odor and the concentration that is capable of causing adverse effects are similar. Some chemicals and gases, specifically propane, has no odor, so the propane manufacturer adds an odor to the gas, so it can be smelled, indicating the gas is in the air. Benzene is a carcinogen, so there may be no safe level of exposure. All contact with the chemical should be reduced to the lowest possible level. The workplace exposure limits of 1 part per million is for air levels only. When skin contact also occurs, you may be overexposed even though the air levels are less than 1 part per million time-weighted average. The best method of reducing exposure is through engineering controls. Enclose operations and use local exhaust ventilation at the site of chemical release. If proper engineering controls cannot be effected, respirators should be worn. A regulated marked area should be established where benzene is handled, used, or stored as required by federal or state regulations. Post hazard and warning information in the work area. Wear protective work clothing. Wash thoroughly immediately after exposure to benzene, before you eat or drink anything, and at the end of your work shift. Where possible, automatically pump liquid benzene from drums or other storage containers to process containers. Contaminated work clothes should be laundered by individuals who have been informed of the hazards of exposure to benzene. Eye wash fountains should be provided in the immediate work area for emergency use. If there is the possibility of skin exposure, emergency shower facilities should be provided. On skin contact with benzene, immediately wash or shower to remove the chemical. At the end of your work shift, wash any areas of the body that may have contacted benzene, whether or not known skin contact has occurred. Do not eat, smoke, or drink where benzene is handled, processed, or stored, since the chemical can be swallowed. Wash hands carefully before eating or smoking. Many scientists believe there is no safe level of exposure to a carcinogen. It should also be treated as potentially harmful to reproductive organs. Repeated exposure can damage the blood-forming organs, causing a condition called aplastic anemia. This may cause death. Exposure to benzene can cause drying and scaling of the skin. Before beginning employment and at regular times after that, a complete blood count should be taken. Any evaluation should include a careful history of past and present symptoms with an exam. Medical tests that look for damage already done are not a substitute for controlling exposures. You should request a copy of any medical testing provided. The information provided in this program is only a guide and may not apply to every situation. Workplace controls are better than personal protective equipment. However, for some jobs, personal protective equipment may be appropriate. Wear solvent-resistant gloves and clothing. All protective clothing should be clean, available each day, and put on before work. Wear splash-proof chemical goggles and face shield when working with liquid, unless full face piece respirator protection is worn. Improper use of respirators is dangerous. Such equipment should only be used if the employer has a written program that takes into account workplace conditions, requirements for worker training, fit testing, selection of respiratory equipment, and medical exams. Where the potential exists for exposure over 0.1 part per million, an approved supplied air respirator or approved self-contained breathing apparatus with full facepiece. Exposure to 3,000 parts per million is IDLH or immediately dangerous to life and health. All respirator protective equipment must meet federal and state requirements. Prior to working with benzene, you should be trained on its proper handling and storage. Store benzene in tightly closed containers in a cool, well-ventilated area away from heat. Sources of ignition, such as smoking and open flames, are prohibited where benzene is handled, used, or stored. Metal containers involving the transfer of benzene should be grounded and bonded. Drums must be equipped with self-closing valves, pressure vacuum bungs, and flame arresters. Wherever benzene is used, handled, manufactured, or stored, use explosion-proof electrical equipment and fittings. Always follow your company's emergency action procedures. The following information is only a guideline. If benzene is spilled or leaked, take the following steps. Restrict persons not wearing protective equipment from area of spill or leak until cleanup is complete. Remove all ignition sources. Cover liquids with activated carbon absorbent or other approved material and deposit in sealed containers. Ventilate area of spill or leak after cleanup is complete. Keep benzene out of a confined space, such as a sewer, due to the possibility of an explosion. Benzene-contaminated material may be classified as hazardous waste and may require proper disposal according to EPA and other federal or state regulations. If benzene comes in contact with the eyes, immediately flush with large amounts of water for at least 15 minutes, occasionally lifting upper and lower eyelids to get water into the eye. If there is skin contact, quickly remove contaminated clothing. Immediately wash area with large amounts of soap and water. Seek medical attention. If a person has breathed benzene, remove the person from exposure. Begin rescue breathing if breathing has stopped, and CPR if heart action has stopped. You have the responsibility to work and act safely. And part of that responsibility is protecting yourself and others from the potential hazards of this chemical. Know, understand, and follow your company's policies and procedures relating to benzene. If you have any questions, be sure and ask your supervisor. Your health and safety are just too important.
There's been unnecessary deaths as a result of this, and that is going to continue for a period of time to come.
It is a very good building material, there's no question about it. The only problem is now we've discovered that it kills people.
Building trades workers, construction workers, millwrights, engineers, or just production workers who happen to be around the material when it starts to disintegrate or when there's a repair being done are exposed.
There was enough evidence out there decades ago to put a stop to using these products. Why they would have a mineral like that going into homes and schools and hospitals doesn't make any sense.
The hazard is asbestos, and the danger is breathing in the fibers when they're released into the air. Older homes and buildings can have many asbestos-containing materials, such as vinyl tiled flooring. These tiny fibers become airborne during renovation or demolition and become deadly.
Prior to 1978, it was a free-for-all. Use it any way you want. You know, when I started in the early 70s in one of the petroleum plants up in northern British Columbia, I was openly working with asbestos dressed the way I am right now. I mean, other than a hard hat and a pair of gloves. No respiratory protection, no coveralls, no containment, none of that stuff. My task was to take finishing cement off the existing tanks and save it because it wasn't available. You couldn't buy it anymore. Maybe that was the first indication there was some problems.
It's in a lot of building products that were used in industry and in commercial buildings. And people may not believe it, but it's also present in a lot of building products used in houses.
Early 70s, I was doing some home renovation in an old house we had on the east side of Vancouver, and part of that renovation was to sand off an old chimney coming up through the ceiling so it would look, nice. And I'm like an idiot sanding it with power equipment, right, to get the old mortar off. You know how it sticks on the brick. You want to see the red brick. The mortar was full of asbestos, and it was in clouds in my kitchen for a week while I was wearing a little paper mask. So I was heavily exposed then. I don't know what will happen to me. I'm hoping that nothing, as I get older, but that's a typical thing. I mean, I didn't think about it.
If you go and tear something out that's got asbestos in it and you get fibers released and you don't know how to clean up properly and you don't know how to dispose of it properly, you're not only putting yourself at risk, you're putting your other household members at risk, your kids and what have you.
When a worker breathes in, asbestos fibers flow down the air passages deep into the lungs. Immune system cells try to break down the asbestos fibers and become damaged and die. Scar tissue forms around the dead cells. Asbestos fibers can remain in the lungs for long periods, and the scar tissue that results continues to develop for many years after exposure. Eventually, so much scar tissue develops that the lungs stop working.
My dad was very, very health and safety conscious. I know that if anybody had said to him that the products that he was handling could potentially make him sick later in life, he would have taken whatever precautions were necessary. When he retired, without being in any sort of accident or incident, working in a mill and working on high voltage, I think we sort of thought he was safe and that, we didn't have to worry about that part anymore. So, yeah, to learn that what he was dying from was a workplace exposure, it was devastating. The frustrating thing was he'd been healthy his whole life. His parents had both lived to late 80s, early 90s. There was no health issues in his family. So he had every expectation of a sort of a long, healthy retirement. So it was hard.
One of the diseases associated with asbestos exposure is mesothelioma. Mesothelioma is a cancer, but it's a cancer of the lining of the internal organs of the body. So you've got a lining of your lungs and you've got a lining of internal organs in your main body cavity, and this is where this particular cancer hits. If you're going to work on your house, if you're going to disturb this stuff, there are ways of doing it safely, but you have to make an effort to find out what those are. It can be in your ceiling, it can be in your drywall, it can be in your floors, it can be in your attics. Don't just have somebody in and tear this stuff out without taking the appropriate precautions, because you put yourself at risk, you put your family at risk, and the contractor is at risk.
Asbestos disease is the #1 killer of workers in BC. If you're working on an older home or in the renovation or demolition industry, always test for asbestos and only remove it if you are trained and qualified.
If the building where you work was built before 1978, you may have old lead paint on your walls and doors. But that's not the only potential lead hazard in the workplace. Hi there, I'm Dan Clark of the Safety Brief. This is where we talk about health and safety hazards in today's demanding industrial and construction work sites. You may think lead hazards are a thing of the past, since lead has been banned in things like paint. Up till the mid-'80s, lead was an anti-knock additive and octane booster in gasoline. Those are history, but lead still poses a real problem in many workplaces, and I don't mean pencil lead. That's actually graphite. Lead hazards are all over the place in these jobs: demolition of old buildings, metal production, battery manufacturing, plumbing, recycling, bridge work, radiator repair, gun ranges. Yes, gun ranges if people are doing major work like remodeling or disturbing the soil. Health effects of lead. In the short term, headaches, irritability, and stomach pain. In the long term, nervous system damage, you have a tough time thinking, high blood pressure, poor kidney function, anemia, and reproductive problems. These can impact anybody, but they're especially big problems for kids and pregnant women. Lead can impede brain development, and workers often carry home lead on their clothing and expose it to families. What can employers do? 1. Isolate or automate processes involving lead to limit worker exposure. 2. Provide good ventilation to areas containing lead. 3. Provide PPE, including respirators. 4. Provide training about lead hazards. 5. Monitor employees and lead levels in the workplace. What can workers do? 1. Wash hands with cool water, not hot water. That opens up the pores for the lead to enter. 2. Use soaps that remove heavy metals. 3. Shower before leaving the job site. 4. Change clothes and shoes at the end of your shift. 5. Carry those clothes home in a plastic bag to prevent that lead from contaminating the vehicle, and wash work clothes separately. 6. Talk to your doctor about potential lead hazards in your job.
Thanks for taking a little time out of your day to learn about carbon monoxide, or CO, poisoning. Everyone knows it's not safe to leave your car running inside your garage with the door closed. Why is that? That's right, it will make you sick or possibly kill you. So if we don't do that at home, then why are we willing to run gasoline-powered equipment inside closed spaces? In the last weeks of July 2012, Oregon OSHA began 3 separate investigations looking into cases of potential carbon monoxide poisoning. One of these cases affected 23 employees. We typically think of CO poisoning during the winter. A person doesn't clean their chimney and the family is sickened, or the furnace isn't working right and a whole household is sent to the hospital. So why is CO so dangerous? Let's look at CO for a moment. First, it's not carbon dioxide, the gas that we all exhale. CO is an odorless, colorless gas that is about the same density as air. This means that it floats around the room and you can't see it or smell it. It's truly a silent killer. CO also remains in the air for almost 2 months after it's created. So if you have a well-sealed room, it can be there for days or even weeks after the work is finished. Concentrations of CO are measured in parts per million. Since carbon monoxide affects your body's ability to grab oxygen from your lungs, it can affect you in many different ways, from being lightheaded to becoming unconscious to even causing death. For pregnant women, it can also cause difficulties with your pregnancy. Like a kitchen sponge sucks up water, the blood sucks up CO instead of oxygen, and it takes a bit of work to remove it. The good thing is that with a little caution, we can keep everyone safe and healthy. This chart shows the different OSHA limits. The most CO you can be exposed to in an 8-hour day is 50 parts per million. The excursion limit, or the time you can be exposed to a more significant dose, is 150 parts per million for no more than 30 minutes. Immediately dangerous to life and health, or IDLH, jumps to 1,200 parts per million. This is almost 1/5 less than the 8-hour limit for carbon dioxide. So how much is 50 parts per million, or 1,200 parts per million? This is a difficult thing to really comprehend because I've never seen a million of anything. So let's look at a demonstration.
When we talk about 50 parts per million, what we're talking about is 20,000 drops for a liter of water. So one drop makes 50 parts per million.
Please remember that one drop, or 50 parts per million, is the amount OSHA considers safe for an 8-hour workday. More than that can start causing serious health problems.
So 50 parts per million is one drop from a dropper into 1 liter of water. And you can see how tiny that is.
It's a big area. I'm not completely inside. Or how about this one? I'm not right next to the equipment. How do you know if you're at risk? If you use any power or heating equipment that uses carbon-based fuels, be aware that CO can be an issue. These are typical symptoms of CO poisoning. If you are using one of those fuel sources and suddenly have these symptoms, move to fresh air. After you move to fresh air, then reassess if CO is an issue by monitoring the area. Here's some tips on how you can protect yourself. First, if you're working with carbon-based fuels, make certain that there is adequate ventilation and that the ventilation moves the bad air away from people and outside to a safe distance. Preventative maintenance on equipment can also help keep employees safe. Detectors are inexpensive and can be stationed around the work area when powered equipment is in use. Permanently mounted detectors found the workplace as well. When questions come to mind, let us help. Employers, if you would like to get personalized recommendations for your Oregon job site, call for a free confidential consultation. Our consultants would be happy to give you all the details. When it comes to carbon monoxide, don't become a statistic. Have a plan.
This course is designed to provide you an understanding of defensive driving techniques and your responsibility as a driver of a motor vehicle. Defensive driving is an attitude you must have every time you get behind the wheel. Drivers who drive defensively are less likely to have accidents. Always maintain good vision ahead and around your vehicle. Stay alert and be prepared for the unexpected. Anticipate mistakes or unsafe maneuvers by other drivers. Always obey traffic signs and signals. Allow extra space between your vehicle and heavy equipment, motorcycles, bicycles, and pedestrians. Don't drive in other vehicles' blind spot, and don't weave in and out of traffic. Stay in the middle of your lane. Pay close attention to crosswalks, playground and school areas, congested and shopping areas. Defensive driving starts even before you get in your vehicle. It begins by a walk around your vehicle to ensure there is nothing in front, on side, or behind the vehicle that you could hit or run over as you pull out. During this walk around, you should also visually check each tire for proper inflation and damage. Underinflated tires can overheat, which can cause sudden sidewall blowout at highway speeds. Also check for broken headlights, taillights, and turn signal lights. After you get in your vehicle, check alignment of side and rear view mirrors. Adjust your seat so that you can comfortably use the brake and gas pedals and adjust the steering wheel. It is essential that you keep your vehicle windows clean. Sun and rain can make a dirty windshield almost impossible to see through. During early morning and late afternoon, when the sun is low on the horizon, it can be difficult to see on roads that go east and west. Keep a good pair of polarizing sunglasses in your vehicle. Good sunglasses can also prevent eye strain during bright driving conditions. Fasten your seatbelt snugly. It is designed to save your life in an accident. Don't put anything on the dashboard or on the rear window deck. Heavy objects should be placed in the trunk. If you will be driving an unfamiliar vehicle, take time to learn where all the controls are before you start driving. At least once a week, take time to check under the hood. Check fluid levels for oil, power steering and brakes, engine coolant, transmission, and washer fluid. Also, be sure to frequently check engine belts for wear and cracks. After starting the engine, check that all engine lights clear. Check that turn signals work. When entering traffic, be sure you have plenty of space. Allow traffic to clear. Never try to squeeze in by rapid acceleration. You could lose control of the vehicle. City driving has its own specific set of hazards. Traffic may be dense and continually stop and go. Be sure to keep your eyes on the road and vehicles ahead. Be aware that sudden stops are a part of city driving, so provide adequate following distance from the car ahead of you. Another hazard of city driving includes cars pulling out of side streets and parking areas. Also, be prepared for pedestrians entering the street between cars. Watch for and expect driver's side doors to open from parked cars. When driving in unfamiliar areas, be sure to keep your speed down and watch for traffic signals and road signs. Approach all crosswalks with care. Not all pedestrians will wait for traffic to clear before crossing. Residential areas have their own set of hazards. Watch for children and cars backing out of driveways. Fences may create blind corners at intersections. Be sure you pull into blind intersections slowly to be sure cross streets are clear. During the school year, expect heavy traffic and school buses in residential areas in the mornings and afternoons. Highways and interstates allow traffic to move quickly to their destinations. However, you must be ready to stop or slow quickly for road construction, urban congestion, or accidents. Give yourself plenty of following distance from the car ahead, 1 car length for every 10 miles per hour of speed. Drive ahead. Don't just watch the car in front of you. Be aware of what traffic is doing well ahead of you and frequently use your mirrors to monitor traffic behind you. When changing lanes, be sure to check clearance in the lane next to you before moving over. Be aware of on-ramps ahead and give merging traffic room to enter the highway. When traveling highways, keep to the right unless passing. Never stay next to trucks. Either drop behind or move ahead. Don't stay in a trucker's blind spot. Driving in the country has hazards that don't exist in residential areas or on highways. Be prepared for rough, uneven roads, loose gravel, and potholes. Slow down on unfamiliar roads. Not all sudden curves may be marked. The countryside may also have farm equipment crossing or traveling the roads. Animals may also be on the road, so continually scan left and right. Many accidents are caused by a distracted driver. Don't divide your attention while driving by using cell phones, having extended conversations, or looking at roadside scenery. Even the short time you are distracted adjusting the air conditioner, lighting a cigarette, eating, drinking, or changing radio stations can be enough time with your eyes off the road to cause an accident. Emotional distractions can also make you a hazardous driver. Before you drive, make sure you can maintain complete control of yourself and the vehicle. Driver fatigue is a major cause of highway accidents. When taking long trips, be sure to start rested and take a break every 2 to 3 hours. Get out and stretch. Know your limits and don't drive longer than you should. Stop overnight on long trips. Drivers who drive defensively are less likely to have accidents. Always maintain good vision ahead and around your vehicle. Stay alert and be prepared for the unexpected. Anticipate mistakes or unsafe maneuvers by other drivers. Always obey traffic signs and signals. Allow extra space between your vehicle and heavy equipment, motorcycles, bicycles, and pedestrians. Don't drive in other vehicles' blind spot, and don't weave in and out of traffic. Stay in the middle of your lane. Pay close attention to crosswalks, playground and school areas, congested and shopping areas. We hope this course has encouraged you to be a good, safe, and courteous driver. Buckle up and drive defensively.
You've probably seen these around loading docks or trucking yards, and for good reason. Wheel chocks, often called wheel stops or wheel blocks, prevents your vehicle from rolling when parked, which is super critical if you happen to be unloading or loading the bed or underneath the vehicle doing repairs. And these prevent wheel chocks will keep you safe no matter your vehicle. Picking the right wheel chock may seem easy, but if you have a chock that's the wrong size, it's basically useless. There are 3 pieces of information you need to help you find the right chock for the job. First, you need to know how much a vehicle will weigh while carrying a load, because each chock is rated to a specific weight capacity. The heavier the vehicle, the stronger the chock needs to be. Next, find out the tire diameter. This is one of the most important steps when selecting the right wheel chock. Each size of chock has a maximum tire diameter listed, from 26 inches all the way to 59 inches. If your tire is greater in size than the maximum diameter listed, you may find the vehicle rolling away on you when you least expect it. Last, you're going to want to determine how many chocks you need. This is going to depend on the situation. If your vehicle is parked on a level surface, you'll want to chock the front tires on both ends. This ensures that your vehicle can't roll either forwards or backwards. Make sure to place the chock squarely and firmly in the middle of the tire tread, with little to no gap between the surface of the chock and the surface of the tire. If you're parked uphill, chock the rear tires on both sides of the vehicle. Finally, if you're parked downhill, chock the front tires instead. So if you want to be safe, having 4 chocks on hand will ensure that you're always covered, no matter the situation. These safety devices are typically made out of rubber or urethane, and each material type has its pros and cons. Rubber wheel chocks are the most cost-effective option and are reinforced for multi-surface gripping and reliable performance in all climates. Here at Greg's, these Prevent chocks are available for tire diameters from 26 inches to 37 inches, with a standard design, a metal eye bolt, or with a carrying handle for easy transportation. Now, urethane chocks, on the other hand, aren't nearly as heavy as rubber. Because urethane is so light, the chocks are easier to position quickly and correctly. They're super resistant to impact, wear, water, and oil. They will not rot, rust, or crack in the presence of heat, cold, or moisture. Over time, all these things will happen to rubber chocks, so a urethane option is definitely a long-term solution. They're bright orange for enhanced visibility and are available for tire diameters from 29 inches all the way up to 59 inches. So no matter your wheel, you can rest easy knowing your vehicle is secure. We also carry aircraft-style chocks, which are designed for smaller off-road vehicles like an ATV, with tires no larger than 27 inches in diameter. The rubber chocks are connected with a 36-inch rope, making removal quick and easy so you can get back on the road fast.